sort of go to. Now we're going to finally get started kind of on the code. We're a little bit, maybe a few days behind where I had that scheduled, but that is what it is. So we're kind of getting into actually writing code, writing the applications part of this. So what we're getting into is something called Node. You should already have it installed, kind of as part of the install instructions previously, and we'll kind of talk about it and we'll start using it today. We're also going to finally get into actually using VS Code and kind of talking about how that works, and because that's going to be our IDE of choice. Okay? So outline for today, I've got kind of a few things we need to talk about. We're going to talk about what Node is, and some kind of the background there. We're going to review a little bit of JavaScript. Again, we've got a handout that I'm going to give you for that to review a few things. When you went through your first semester course, some of you went through the 4th edition book of the JavaScript 4th edition book. Some of you went through the 3rd edition book. The 3rd edition book was about 5 years old, released in 2015. The 4th edition one is 2020. There are a few things I'm going to have to get you up to speed on, suffice it to say. So that's part of what we're talking about today in terms of reviewing JavaScript, is getting those fundamentals, as well as talking about what has changed in the JavaScript world. Okay? So some new syntax I expect you to use. We're going to do a little quick example, building a console app and kind of seeing how that works. We're going to talk about NPM a little bit, which is short for Node Package Manager. And then we're going to get you started on Lab 0301. The homework for tonight is to continue with Learn Node.js on the results. Cool? I would strongly advise giving a piece of paper out to take some notes, because there's going to be a good number of things that we need to go over to today, and you'll definitely want to go back and refresh yourself on those things.
This is the Node.js part 1 lecture.
Those, I've decided to go a little bit of a different direction. So there's the part 1 and part 2 is kind of my slides from last year.
Okay.
I'm going to veer off and go a little bit of a different direction than those slides.
Okay. Is there like a clean slides or something to follow along with?
Yeah. If you look at the Discord, and it's also on Inside Ranken now, you'll see that there's my kind of lecture outline, which I have up here. So it's kind of the outline of what I'm going to be talking about today. Okay. So first thing to understand about what Node is, right? So from the reading, you should have read a little bit about Node. How is Node defined in the reading assignment that you were given? How did they define Node?
It was a tool used to run JavaScript outside the browser.
Yeah.
We call it a runtime environment.
We call it a runtime environment. So there's a few different kind of words that we tend to use for different technologies that we work with. IDE, integrated development environment. You've got libraries, you've got frameworks, you've got different kind of things, right? So a library would be somebody else's kind of set of code that you're using in yours. A framework is maybe, it's still somebody else's code that you're using, but it's more foundational where all your code's built on top of there. So Node is referred to what's called a runtime environment. It's a runtime environment. What that means is it's a way to run code. It's something we can run code in. And specifically, it's for running JavaScript code. So it's a runtime environment for JavaScript code. It is based off of the Google's V8 engine for JavaScript. Around 2010, Ryan Dahl kind of had this smart idea after Google was kind of Chrome was kind of a new thing, and they had this new fancy JavaScript engine called V8, which is running JavaScript really blazingly fast to compare to what had come before. And said, well, what happens if I take this engine and pull it out? So rather than running it in the browser, we just build a little console that you can run JavaScript code outside the browser, and that's kind of where Node was born, right, as a way to run JavaScript code outside the browser. It's actually that whole process, that whole instigated a lot of changes in the development industry, the soft web development industry at large, and even expanding beyond just web development, because it really allowed us to do a lot of things, allowed a lot of growth with JavaScript that hadn't really been there previously, right? If you know anything about the history of JavaScript, JavaScript was invented by some guy at Mozilla in about a week, right? So, JavaScript's this kind of weird language had an interesting sort of origin story. And from that, well, for the longest time, it wasn't really seen, JavaScript was not really seen as a real programming language. You could do a little bit of stuff on the web and maybe glue some things together, but you also then have the problem of like, well, does it run on Netscape and does it run on IE, and having to write completely different code to support all of these kind of differences. So there was a lot of kind of problems there. Now, one of the things that's happened since kind of that origin of Node, since it's allowed us to now build applications outside of the browser in actually kind of an environment that we have control over, because we can control the version of Node we have installed. We can't control a version of browser that somebody has installed. It's actually led to a lot more standardization in JavaScript itself, and led to a lot of features being added because we could iterate and standardize a lot quicker. So that's been a really cool thing. It's really led to a lot of growth in JavaScript. In fact, previously it was kind of this joke language, like why, it's everybody has to know a little bit of JavaScript, but it wouldn't be the main language you programmed in. Well, now for a lot of people, it's the language you program in. You can write entire applications just JavaScript. Whether that be console apps, whether that be even GUI desktop applications, including VS Code actually is built on JavaScript, believe it or not. It's built on something called Electron, which has got some similarities to Node. It's basically kind of a browser in a box sort of thing. So even large-scale applications are now built on JavaScript. And the one we're specifically concerned with today is building web servers and web applications, which we're going to be building on top of that. So that's our goal, right? We want to be able to build web servers and web applications on top of this Node kind of runtime environment, and using JavaScript as our kind of language. Okay, so that's kind of where we're going. So in terms of making sure that you have the latest version of Node installed, that's where we want to kind of start. You should have downloaded it already from Node.js.org, which is this website. So you should have already gotten the current version installed. Okay, so the current version right now is 16.9.1. They release this pretty frequently, so your version that you have installed, even if you did it at the beginning of the semester just a few weeks ago, might be older than that. Okay, but 16.9.1 is the latest. What I want to do is make sure that we have everybody's got that installed, so we can do some things today, some playing around, as well as making sure everybody's got at least a recent version of it. So if you go to your start menu, you're going to type in CMD like I did to get back into your command line, kind of like we were doing with Mongo Shell. So I'm going to pull up that command prompt. Zoom in here a bit so you can see it. And in there I'm going to write two commands. I'm going to write node-v. I'm going to hit enter. I'm also going to write npm-v and hit enter. Okay, so I want you to run both of those commands on your computer, and I'm going to come around and just check and see where everybody's at. So you'll see right now I have 14.15.1 and 6.14.8, and I think that means I need to update my node. So I got a few people who need to get up to date, and I need to get up to date myself too. So I'm going to go grab that. And yeah, there's not much configuration. It used to be that there was none, so they added this chocolatey, which I don't completely understand what it is yet. I think it's a a way to try and get it to auto update, but I'm not too familiar on what that is. Okay, so we're going to do all that. Next. Yeah, so I'm not going to check that box. I'm going to just leave it unchecked.
Interestingly, mine was automatically checked, right?
Yeah, I think mine was unchecked because I went through this previously and unchecked it. Yeah, so I don't know what all that's about yet. But I know as far as our class is concerned, once we get it installed now, you won't need to update it anywhere in the rest of the semester. So yeah, it's not very big. Like Node is pretty tiny, which is actually one of its big benefits. Compared to some of the other technologies out there, you need a lot of files just to start running. Like the base install for Java is ginormous. Same thing for C#. You need basically all of VS Code to start writing code. So Node is pretty tiny, which is amazing, and it hasn't allowed us to put it on very small, low-power devices, such as like you can run it on a Raspberry Pi, tiny little computer, and deploy a web server or other applications that way. So that's really cool. That's one of the things that that's kind of missing in here, is that not only can we run these web servers and run them on our traditional servers, you can actually just set up a web server for your home or your business running on a Raspberry Pi, tiny little device like that, and great. It can run a lot of small-scale applications without a lot of heavy server hardware. I forget how much a Raspberry Pi is going for today, but I think it's anywhere from $20 to $100. It's a really cheap machine. Okay, so let me try to run that again. And I'm going to do node-v, npm-v. Okay, so what I'd like to see here is for everybody to be at 16 or higher as that major version, and 6 or higher for the npm version. Okay. Is anybody not there yet? I saw a number of people on 12. Okay. It shouldn't make too much difference, but I want to make sure that we're all kind of at the same place because there have been some changes. Okay. So that's good. So that's basically how you check those things. And you kind of saw in there when I was doing the shell. So you've got node is kind of is the way we're going to run and execute code. And you've also got npm in there is what we call our package manager. And so npm is going to allow us to install code that other people have written, for instance, is basically where that fits in. And we'll actually be using that quite a bit for a number of different projects out there that are just really common and really useful. Okay, so Node does have a library that's built with a lot of stuff in it, but there's a lot more out there beyond just what is built into Node. So I'm going to go back in my shell. I'm going to talk about a few things here. So we kind of talk about what Node is, right? It's this environment to run JavaScript in here, and I can use it actually in an interactive mode. So if I just type in Node, not with the -v, -v just said give me the version. If I just type in Node, all of a sudden I get this little prompt here. It says welcome to Node 16.9.1. Okay. This is basically a JavaScript terminal. I can write JavaScript code in here and just test it. So let's say I want to write 2 + 2, just something simple. Hey, tell me it's 4, right? If I want to get, let's say, hello plus world. Yeah, it's already starting to fill this in. And this should look very similar to you because you've actually kind of seen this console before. If you've ever looked in your browser, you kind of know there's a console, a terminal built into your DevTools in the browser. This is the same thing, actually, just in the command line, right? So we can write things directly on the console if we just want to kind of test things here. And this is kind of what Node does, right? This, though, is not all that helpful, right? This by itself is not all that helpful. So what we generally do is we write scripts, and then we have Node execute that script. Make sense? So I'd write a script, and then tell Node to execute it. All right. So how do I do that? How do I build these scripts? So what I'm going to do is I'm going to make a new folder on my desktop. And I'm just going to call this folder Hello World. So new folder, Hello World. Okay. So right now there's nothing in there. Depending on how you set up VS Code, you may be able to right-click in here and open with code, which is usually what I do. I usually right-click here and go open with code. And that gets me directly to the folder. Now, I think a few people don't have that on their system, right? Okay. That's useful enough. I think it's probably worth us making sure that everybody has that functioning. The way to do that, unfortunately, there's no way to just go into VS Code and change a setting. The way to change that is you actually have to do it during the install process for VS Code. Okay, so what we want to do is go out to the VS Code website. I'm just going to look for VS Code. So it's going to be code.visualstudio.com. And what I want you to do, if you don't have that option, is I want you to go download VS Code again, and we're going to reinstall it and pick the right option. So I'm going to hit download on that. All right, accept the license. Okay, hit next. Okay, so you're going to see there's a few options here. Okay. By default, the only one that's checked generally is this last one, add it to the path. You'll see the one, the second one here that I have checked. Add open with code action to Windows Explorer directory context one. Check that second box. Don't check the first one, just the second one. If you do that and then run the installer, you will now have that option. That's it. Yes, sir. The second one, not the first one. Open the directory one. So make that Hello World folder. So once you get it installed, you can open up that folder. Yep, that's what you want. So you have to open up the code. That is somewhat a minor thing. It's kind of, in some sense optional, but it really can make it quicker to kind of get up and running and do a lot of things if you have that option there. As far as looking in here, hopefully this is not your first encounter with VS Code. Just to make sure everybody's on the same speed. You've got your main kind of window. This is where we're going to work with our code. You've got a sidebar, which actually changes between a few different things. So you'll notice right now I'm on the File Explorer, which is this one up here. There's also a search. There's a source control option here, which we'll be using to work with Git, so that we can actually directly push our code and pull code, etc. We can do that, all of the stuff we get directly there. Run debug we won't be touching. There's an extensions. There's several extensions that you should have installed already. If you don't have those installed, go back, check the install instructions for the beginning of the semester. And then you may or may not have, if you have the Mongo extension installed, you may have this window as well. So that's kind of what's happening on the left. So I'm going to go back to Explorer, and in Explorer, I'm going to right-click in here, and I'm going to create a new file. Okay, so the new file I want to create is index.js. Okay, so this is my JavaScript file. You can see it with the JS extension. Now the difference here is this is JavaScript that I'm going to run through Node instead of how we would traditionally run it in putting it into a web page kind of thing, right? So this is going to run completely outside of a web page. Okay, so let's do some simple testing. You may remember in JavaScript that you can use the console statement, say console.log, to write things out. It's really helpful for debugging purposes. Okay, so maybe I say console log hello world. And put that in there real quick. You end it with a semicolon. It's worth briefly noting that semicolons are entirely optional in JavaScript. They are not required. I would recommend you include them, but they are optional. So I can pull that up. I can start writing some code in there. The next thing I want to do is actually run it. Okay. So I could go and do this and run it. I could open the terminal as a separate window, kind of like we did. We had Node open in the terminal. Oftentimes, I'm going to be doing enough with the terminal that I actually like to have the terminal embedded, use the terminal within VS Code. So if you look at the top of the window, you'll see that there's a little tab, a little thing in the menu bar called Terminal. I'm going to click on that, and I'm going to say New Terminal. Okay. That's going to pop up a window down towards your bottom. You can resize it as you need. There, also resize here. Okay, so when I pull this up, this is going to be running whatever your kind of default shell is for your operating system. So for Windows, that's typically going to use PowerShell. It could also be CMD, right? CMD is kind of the old MS-DOS sort of emulator for your shell, versus PowerShell is the kind of the newer version in Windows of the shell. I think, Michael, you're going to have a little bit of a different shell in there, but you should still have a similar syntax. On here, you may have an option like this. I have a PowerShell little button. That will actually allow you to change, if I remember right, change, oh no, it's not there. That's the window that's open. If I hit plus here, there we go. So if you hit plus, you'll see that there's a few different, there's other kinds of terminals that you can open. So for instance, if I wanted to do CMD, I could open the CMD window here instead. If I wanted to use bash instead, which we got with Git, I could run bash shell as well. So depending on kind of what makes sense for you, I'm going to be doing all my examples with PowerShell, right? So if you're not on PowerShell, I would ask that you switch it over to PowerShell. You notice it says PowerShell default. You can do that by going there, the bottom option, select default profile. That'll give you the options that are available, and just switch it to PowerShell. Okay, because PowerShell and CMD are similar, but slightly different. Okay, so some of the commands may or may not work, may work differently depending if you're on PowerShell or CMD. Okay, so one of the nice things about the terminal that's built in, not only is it quick to get to, it's already in the folder for our project. So you'll notice where the path is. C users, Paul Smith, desktop, hello world. So that's the folder that we're currently living, which turns out is the same folder where my code is. Okay. If I want to list the files that are there, I can hit LS and enter. And that should list any of the files that are there. That's a good way to kind of check that you're in the right place. So if I do ls, you can see that there's an index.js. Michael, that should work for you. You should have an ls command as well. So that's listed. Cool. So that can be helpful to get around. Other thing that's worth noting in here, you can use CD to change directory. So if I want to go up and down the hierarchy, I can do that as well. So let's say I wanted to go up a folder, I would do CD ... And that would, as you can see, take me up to the desktop folder, right? So that would take me up a folder. If I want to go down a folder, then I would say CD hello world, and we can get back down to our hello world folder. So ls and cd are really good commands to have kind of in your back pocket to make sure you can navigate and be in the right place. Okay? But the upside of the thing is basically all of our commands, we're going to run in whatever the project folder is. So for this, it's hello world. We're going to run all of our commands from that folder. Cool? That's kind of an important detail. But that's how you can navigate around. Okay. Now that I'm here, what I'm going to type in is node space and the name of my script. So node index.js and hit enter on that. So if I do that, great. There I've got hello world. So it actually ran the script that I wrote. Script wrote out hello world. We're good. So running your scripts with Node is pretty easy in that sense. You just need to know, hey, type in Node and then the name of the script. Okay, that's like the basic syntax that you need to know. That's how you're going to run these programs. Okay. This is a very simple program, obviously, right? So we want to kind of amp this up, and we're going to get to some more complicated programs as we go through this. Cool. One of the things that you'll notice here, I've called this file index.js. Typically for Node, that's kind of the starting point, the entry point for your application. Okay. Generally speaking, the first file that the program runs is going to be index.js. When we get to our web servers, actually, though, I'm going to ask you to name those specifically server.js. That is going to be in the lab instructions, but that's what it'll be when we get there. For your console labs, I've given you specific names for what to call those programs. Okay? But index.js, you'll commonly see that. If you're looking at a Node application and trying to figure out where to start, where the program starts up, look at index and follow it from there. Okay? So that's kind of the intro to what Node is and a little bit about how we're going to use VS Code. Questions so far? That kind of makes sense? Okay. So let's talk about JavaScript, because that's kind of the language we're using here. So we have a handout for you. Here we go. On here are a few things that you'll need to remember, especially if it's been a while since you've done stuff with JavaScript. So here's a few things to refer back to. I will be talking to you what's on the sheet, so you have an idea. Okay. Okay. So there's a few things on that sheet. There's a table about, declaring variables. There's a table for the data types that are in JavaScript. We've got a little section on this idea of truth and falsity. We've got some stuff about writing loops, as well as a little bit about functions. Okay, that's a good place to refer back to as you're kind of working through the labs. Will give you some of the fundamentals of this language. Now, I do want to go over kind of the bits in there and talk about them piece by piece. So let me pull that up here. Oh, that went to the other screen. So I'm going to go over here. There we go. Okay, so first thing we need to talk about, kind of reviewing JavaScript, actually, is one thing I need to talk about before we get into the sheet. I briefly said console log here is one way you can log things to the console. Okay, so that's one way that you can write things out. Console log is basically when you're saying, hey, this is something that happens. It's a really good debugging tool for any application you're building. We will, on Friday and in the reading, you will probably hear about something called debug. Debug's kind of a better tool than console log, and we'll be using that going forward. But for now, I'm just going to be using console log. And the other one I want to show you is console.error. So there's two methods here that are worth knowing. So console log, console error. If I say here something went wrong and save that, run this script again, I'm going to CLS to clear the screen. You're going to see that coming out. Okay. Now, typically speaking, console log is going to be shown in black, and console error is going to be shown in red. Okay. That doesn't happen here. If you're looking at VS Code, you'll kind of notice that VS Code is just writing them out in that same color. But generally speaking, we're going to kind of keep that thing in mind. So generally speaking, we're writing errors out to the console error, and we're writing informational messages, other messages out to console log. Okay? So the program crashes or something, write it out into error instead of writing that out into log. That's one little detail to know about there. Okay, so let's talk about variables. So I'm going to make a new file here. I'm going to call it vars.js. And what we want to talk about is how can we declare variables in JavaScript. Okay. Now, in JavaScript today, there are 3 different ways to declare a variable. Okay. So let me declare a few of those here. So I can say const x is 1, let y is 2, and var z is 3. Okay, so you can declare variables using any of those 3 syntaxes. Okay, I can declare a variable as with the const keyword. I can declare a variable with let. I can declare a variable with var. Okay, all of these are possible. There are some distinctions though between each of these 3 things. Okay, agree with me there? One thing I will mention. Const is not constant. Don't make that mistake in your head. Const is still a variable. All 3 of these are still variables. So const doesn't mean this is a constant. Okay, that's a common confusion. It actually doesn't mean constant. It means something slightly different. So with the variable, typically I can give it a new value, right? So we call that reassignment. I can assign a new variable to that variable, to a new value to that variable. So for instance, let's say, hey, I want to set x to 5. Okay? So I save that. I'm going to say node vars.js. Try to run this. Okay? As soon as I run this, it's going to say, hey, assignment to a constant variable. Okay? So the thing to know about const is const restricts you from being able to reassign it. Okay? If you declare a variable as a const, you can assign it once when you declare it, and then never assign it again. Okay? You get to assign it once and never again. That's what the const means, is that it can't be reassigned. Okay? It doesn't mean const, it means it can't be reassigned. In other languages, in C#, the word they use is read-only. In Java, the word they use is final for this same behavior. So you can kind of keep that in mind. So that's what you're going to see. If you try to reassign a constant variable, it's going to give you that complaint. Okay? So what I do is you're typing in the wrong place. Yeah. So when I did it down here, it just popped up into it instead of actually like running, because you didn't save the file. Okay. So you need to do a Control-S or go to the file and save all of it. If you see a little circle on your tab, that means you have unsaved changes. So if you're looking here, you see the little circle up in the top where the X is, that means that you have changes that you haven't saved. And so if you try to run your code and you have that, you're not going to necessarily get results you would expect. Okay? So that's what happens. Okay? This is a good thing. This is a good thing. Having constant variables really avoids a lot of errors that people make. And if you get in the habit of using this const all the time, it will end up making your code much better. You'll end up making your code much better, believe me or not. That will make it a lot easier to read the code that's occurring, and part of that is it's a question of cognitive load. right? If I know that a variable can never be reassigned, I can look at the one line where it's assigned and know that that's what value it will have for the rest of the program, the rest of that function. If it's not constant, then I have to constantly keep a tably in my mind about what the current value of that variable is. Does that make sense? So it really reduces your cognitive load if you can have more consts. Okay? So I'd really stress to have const wherever possible. One of the things you're going to find is you can use const in a lot of places where you didn't expect that you could use it. It's part of why I say it's not technically constant. Okay? There's a lot of places where it looks like, well, that wouldn't work, but it does. So start with writing all your variables const. If you get into a situation where you do need it to change, then and only then should you change and use one of the other keywords. Cool? Only if you absolutely can't get it working with const should you use one of the other ones. Okay. So let's try setting y instead. So we saw that we can't set x because it's constant. Let's see if we can set y. Okay. So now if I run this, okay, well, it seemed like it ran without crashing. Maybe I should do a quick console log and see if I can see all these variables. Or maybe I just console log y, just to verify that it changed. Say that, run it again. We're going to see, okay, cool. So basically the way this works is that both let and var, y and z, those two, can be reassigned. Const cannot be reassigned. Let and var can be reassigned. Okay? That's the distinction between those two. Okay? Here's one of the things to kind of understand from a historical standpoint. From a historical standpoint, remember JavaScript was invented in about a week. Okay? When JavaScript was originally introduced, the only one of these we had was var. Var was the only way to declare a variable. And it had a lot of bugs. Right? There's a lot of issues and weirdness that happens with var, which has persisted because we didn't want to break everybody's code. Does that make sense? So var has a lot of weird and quirky bugs that kind of stem out of that short development cycle of JavaScript itself. We'll talk about kind of what some of those are, but the big thing I want you to understand is you shouldn't use var under any circumstances. Okay? Every variable you declare should either be const or let, should not be var. Okay? So that's kind of why we're having this discussion, right? You don't want to use var at all, period. In fact, I'll be taking points off of your assignment if I see var. That's kind of in the rubric. You'll see that on the lab side. Okay? It's that big of a deal, right? It's that big of a deal that I need you to get in the habit of not using it.
So how come we haven't started like phasing out var?
So in some sense it is kind of. So remember we kind of over the summer we introduced this idea of ESLint, linters. So if you set up the linter in a certain, if you set up the linter the right way, it'll actually give you a warning every time you're using var. It'll actually flag it. And so that's the way that we've kind of discouraged people from doing it, is we've set up a linter to flag it every time and mark it as an error every time you use var.
Is there ever a situation you want to use var?
No, there is not. That's the short answer. No, there is not any valid reason to use var. Okay? So let's talk about what the difference is and why some of this exists. So var has a quirky behavior that it is what we call function scoped. Okay? var is what we call function scoped, whereas const and let are what we call block scoped. Block scoped is what you're used to doing with every other programming language. It means that when you declare it in a block, it's scoped to that block. Does that make sense? It's like if you declare it inside a for loop, it only exists inside of that for loop. If you declare it inside an if statement, it's only inside of that if statement. Declare it inside a function, it's only declared within that function, right? You can think of a block. A block is anywhere you've got curly braces, right? In fact, I can declare a scope without even needing any of those structures. You can just do curly braces. So if I just say curly brace, const a is 3. This variable is scoped to that curly braces. I can't just go down here after the end of that block and say console.log a, right? Because if I go down here, I'm going to get error because it's not available, okay? Which is what you would expect to happen. Does that make sense? You would expect this to be an error because this variable a is declared up here. Okay, here's the difference. Let's make this var. Okay, the way var works, because it's function scoped, what it does is it takes the declaration of this variable and moves it to the top, hoists it, as we would say, to the top of the function. So this is valid. Rather than this giving you an error, this works. Tracking with me? So let me kind of write out a function and we can see how this operates. You can definitely follow along if you want to. I'm going to go ahead and get rid of everything I have here. And so I'm going to say, let's declare a function foo, and I'm going to have a variable here, x is 3. I'll create a scope in here, var y is 5. And at the end, I'm going to say return x plus y. Okay. So I'm going to take those two things and return them. So here I'm going to end up seeing, 3 plus 5 is 8. So let's do a console.log. And what I'm going to pass to it is I'm going to call that function foo. So I'm going to say console.log foo. Note the way the parentheses are, okay? These parentheses here say that I'm calling this function. If I leave it out, I'm actually going to get a different result, which is worth noting here. So if I say console.log just foo by itself, that's actually returning the function variable, right? It's not actually, the functions in JavaScript are actually objects. So here it's just logging the function object. But what I actually want to do is call the function and then log the output of that function, right? Log what the function returns. So do be cautious about including or not including the parentheses, because that's going to change whether the function's being called or not called. I think there. So I'm going to run this again, and you can see that this comes out as 8, right? I kind of would expect that variable in y, right, the y variable, to be out of scope. Right? Kind of if I'm just putting a, curly braces here to make a scope, but you can also do the same thing with an if statement or a loop at something. Okay? Look what happens now if I declare these const. So if I use const or let, which are block scoped, I'm going to get a different error. Okay? Rather than just being happy with that and printing out y, it's going to get down here to line 7, and it's going to say y is not defined. You can kind of see here, says hello world, bars 8, line 7, column 4. So that's the kind of errors that it prevents. It prevents your variables from leaking out to a higher scope, from them being hoisted all the way to the top of your function. Does that make sense? Because that's the normal behavior with var, is that your function is all your variables get hoisted. And because of that hoisting, it leads to a whole host of problems, a whole host of things behaving weird and not behaving the way you would expect them to. Okay? That's why we don't use it, is we're trying to avoid that hoisting. Okay? There's some other issues with the browser that don't necessarily apply here in terms of it modifying the window object, but that's the main reason. Is it's a way, using let and const as a way to avoid a lot of bugs and kind of nefarious bugs with your code. Okay? Cool? So make sure you don't have that circle. Make sure you got it saved. Because we have the variables declared up here.
Oh,
You know, I ditched all that code out. So all that code above is still there, which means there's still a line that's declared at the variables. So it's falling back to the line. So if you kind of look at the table at the top of that sheet, you'll see there's a few things that are marked. Namely, the things that are in red are things that you generally don't want that behavior, or you may not, or that behavior may be dangerous. And the things are green, it's like, hey, this is a good thing, right? So you'll notice there, var, function scope, the other two are block scoped. We've got, if you're using it in the global scope, it can override the window object. Other thing to know, var has this kind of weird behavior that you can redeclare it within this game scope. So I can say var x, and then var x, and then var x. I can declare it as many times as I want, versus constant let, you can only declare it once. Cool. You only get to declare it once. Let you can reassign. You can't reassign const. Other thing worth noting on there is the objects, regardless of which of these three you use, any objects that are held by that variable are still mutable, okay? They're still mutable. So what do I mean by that? Let me just create a new file and we kind of talk about that. So new file, obj.js. What does it mean that they're mutable? So in JavaScript, there is kind of the shorthand that you can use to create objects. There's also shorthand that you can use to create arrays. We've already started using some of that when we were working with Mongo, because it's actually the same syntax. So let's kind of look at what that is. So let's say const person. All right, so I'm going to make a person variable. And what I want to do is I want that person to be an object, right? So let's say I create an object here, and he has a given name of Paul and a family name of Smith. Right? So this actually creates an object, right? An object that has two properties, a given name property and a family name property. Okay, so if I want to access those kind of things, let's say I want to do a console.log, I can access those things by saying like person dot given name, right? And I could also do the same thing with last name. So console.log person dot family name. So we can use that dot operator to access properties of an object. So node object.js. Okay. What? Oh, I misspelled. That's why. There we go. So I can quickly access those properties. So far, so good, right? That ability to create objects just like that, you notice we didn't have to declare a class for the object, is actually really, really helpful, okay? It's one of those things, when you're dealing with JavaScript, one thing to keep in mind is it is a dynamically typed language. It's not a statically typed language. So remember in C#, anytime you create a variable, you have to say what type is it, and that has to kind of stay that type. So like an integer or Boolean, etc. When we create variables in JavaScript, we don't declare their type. Okay, we don't say what type they are. Which is also kind of one of the weird things when you're using variables that are. One of the reasons we also kind of want to use const is because if we make a variable const, well, its data type can never change. Like when I declare it,
it's got the value and the data type, and the data type never changes. If I use let, well, then that's a variable that can, not only can it change value, it could also change data type. So it might be an integer at one point in the code, and it might be a string in another point in the code. One of the things you have to kind of watch for, right? And so consts can help you avoid some of those things, or at least make it obvious when those things occur. Okay, so I can access the properties like this. I can read them, right? So I'm reading them. It's also worth noting that I can change them. So let's say I want to change the first name. I could say person.givenName and assign that a value of, let's say, John. Run that again. And we'll see at the end, so we've changed the first name from Paul to John. Output it, we can see that that worked. Okay. So kind of like you've seen in the C#, got objects we can set and read properties of those objects. But notice here, right, remember I declared this variable as const, right? The kind of general assumption would be, well, const means it's constant, but it's not constant. I can change it, right? It just means that it can't be reassigned, okay? So this here is not a reassignment. It's what we call a mutation, okay? Because what I'm doing is I'm mutating the person object. I'm not reassigning a value to the person variable. Does that make sense? Okay. So I can change any sort of properties on the object with the thing that it's linked to because it's a reference to it. What I can't do here, because it's const, is I can't say person is say given name, family name, and let's say David. If I try to run that, it's going to complain at me about line 5 here, right? It's going to say that that's not legal. So line 3 is legal, but line 5 is not. Okay, does that make sense? So line 3 is what we call a mutation. We're mutating the data, or mutating the object, but line 5, I'm reassigning the person variable. Previously it was pointed at one person, now I'm pointing at a completely different person. Make sense? That's one of the things you have to keep straight in your head. Okay? If it's const, you can't reassign it, but you can mutate it. Okay. Questions?
What about adding or removing fields?
Yeah, that's a good question. So let me comment out line 5 so it's not causing an issue. Let's say I want to say person.age. I could say, well, hey, let's add an age. Person age is now 40. If I log that, we'll see that that has been changed. So I can freely add properties just like that. I just assign it, and now the object has that property. Part of why, hey, I didn't declare class in front of it, and class still doesn't enforce that. But you can dynamically just add properties in JavaScript. Yeah. Doesn't matter. Doesn't matter. This will happen all the time when you're working with the data, because you may have data coming from the database and it doesn't have a certain field, like it doesn't have who is it assigned to. Maybe it's not initially assigned to anybody. Well, then later you add the assigned to field, right? This is not unusual that you'll add more fields later. Okay? As far as removing fields, the way that we do that is like so. So I can say delete, and I could delete the person dot family name. Delete will remove a field, and if that field's not there, then you get undefined. Previously, age would have been undefined before I gave it a value. Okay. So undefined means there's no property there, right? There's not a value set. It's worth noting that undefined is not the same as null. Okay. Undefined means it doesn't have a value. Null means it has a value, but that value is null. Okay, that value is that it doesn't have a value, kind of thing. There is a distinction between undefined and null, and that distinction actually turns out to be valuable in a lot of cases. Okay? Does that answer your question about adding and removing properties? Cool. So you can just, adding it's really easy. You just set them. If you want to remove a property, you use delete keyword. Okay. Let's talk about arrays. So I'm going to add in another array here. Another line. So const numbers. And I'm going to make an array here. And so this is 1, 2, 3. So kind of like using the same syntax that I had for objects. Objects, I use that curly brace to define an object. Square brackets I use to declare an array. Let's say I want to look at and work with that. Okay? So what I can do, let's say down here, I want to do a console log. And maybe we want to just log the first number. So logging the first number would be numbers 0. 0 being the first index. So save that, run it again, and we're going to see it logs that first number as being 1, right? So we use square brackets to refer to an item within an array. Cool? Just like I can do with the objects, I can also reassign values in there. So I can say, hey, let's change numbers 0. Let's change it to 5. So if I say numbers 0, change it to 5, go ahead and run this again. We're going to see that that prints out as 5 instead of 1. So I've changed the value. Okay? So you can reassign values just kind of like we kind of did there. One thing you'll commonly want to do is maybe add more things to an array. There's actually 2 different ways to do that that I might mention. So one way that you can do that is right now we have 3 elements in the array. So index 0, 1, 2. I could say, let's say numbers 3 is 10. Right? And so if I were to log the whole array now, we should see that there's another element in there, which is 10. Okay? So one way you can add more things to an array is just by assigning the index, and it'll suddenly expand the array to make space for it. Okay? That's one way you can do that. I don't recommend that you add things to an array using this pattern. Part of that is one of the things it allows you to do is things like this. I'm going to say numbers 10 is equal to 10. And log that. What happened is I now have an array 5, 2, 3, and you can see it says 7 empty items. There's now 7 undefined slots between indexes 2 and indexes 10. So if you jump forward, it actually expands the array to make space for all of that and make those undefined slots. Okay, so if I were to read, for instance, what's at slot 5, which is in the middle there, we're going to see that come back as undefined. Okay. So you can get undefined from properties on objects that are not there. If that property doesn't exist, you can also get it from an array index that's not defined. Okay. Similarly, if I were to go beyond the end of the array and ask for index 100, I would get undefined for that because there's no index 100 yet. Okay. So the safer way to add things to the end of the array is you use a function called push, and push will add it to the end. So if I do that and then log numbers, we're going to see I've got 5, 2, 3, 10. Okay. So anytime you need to add something to the end of the array, you're going to push it to the end of it. Cool? Keep that in mind. That push method is really, really helpful. There are also a bunch of other methods on the array object itself now in JavaScript, which are really useful. I would strongly advise you take a little bit of time to read up on some of those things. In fact, your Lab 302 will have you work with some of those. Okay? Questions so far? This all kind of makes sense so far, working with arrays, working with objects. You can see a lot of syntactical similarities between what we did with Mongo, with the curly braces and the square brackets, right? Because it's actually the same syntax. Okay. Other things worth to know there. Notice, just like I said with objects, I marked this numbers as const, but notice I'm making changes to that array, right? I can still make changes to the array even though it's marked const because it's still mutable. Okay? It doesn't prevent it from being mutated. What it does prevent, just like with the person, right? So the person I couldn't reassign the person. I can't reassign numbers. So if I go in here and say numbers is an array containing 4 and 5, that is going to fail. And it's going to fail with this same error, assignment to a constant variable on line 11, because I can't do that. So these two things is what the constant prevents, specifically reassigning the variable itself. You modify the data at that object or the array all you want, you can't reassign the variable. Okay? Cool? Cool. All right. Let's see, where am I at on my sheet? So, we've talked a little bit about that. So coming through all that, what's the one thing you need to know about var? Huh? Don't use it because it's function scoped. It has some bugs. Okay. Which of those three, const-let or var, should you use most of the time? Const. You should use const wherever you can. Pretty much simple as that. You're going to find as you get into this, you're going to find that you can build an entire web application with fewer than 5 uses of let, kind of thing. It's very rare. It turns out to be very, very rare that you need the let keyword, and you never need var. Okay? So let's talk about functions. So I'm going to make a new file here. I'm going to call it func.js. So there are a few different ways to declare functions now in JavaScript. Okay, so there's the simplest syntax here, where you can say, hey, maybe I want to declare what's called a named function. And this is using what we call the function declaration syntax. And I can't type today. Function declaration syntax. So it looks like this. Function sum x, y, and I say return x plus y. Okay. So that's declaring a function called sum, right? So sum is the name of that function. It takes 2 variables, 2 parameters, as we would say. The name of those 2 parameters are x and y, and then it returns the sum of those 2. So it adds x plus y and returns it. Okay. So this is your simple named function. It's called the function declaration syntax. And my spelling is off. Okay. So this one's been in there for a long time. This is one you probably already know. There's another slightly different syntax that's similar that you can use. So I can say const sum is equal to function x, y, return x plus y. Okay, so this here, notice that this function doesn't really have a name. I'm saving it into a variable called sum, but the function itself doesn't have a name. So this is an anonymous function. And I'm using it kind of in the context of a larger expression. And so we call this the function expression syntax. So this is a function expression. Okay. Part of the reason that that's relevant is I can take this function expression here and pass it to another function. I can take this function and throw it around as an object as far as that's concerned, right? But it doesn't really have a name. Okay? So you got function declarations and you got function expressions. Everybody good with me there? These will definitely be ones you encountered in first semester. The third kind of function is what was called, it makes an anonymous function. And this is what we call the arrow function syntax. And it looks a little bit like this. So I can say const sum, maybe I need to number these, sum2, sum3, x, y, x plus y. And what you're going to see is that it's a little bit more abbreviated, this arrow function syntax. So this is kind of shorthand for declaring a function. So there's a function here that takes two parameters, x and y, and then it does something, or returns something. So what it does is it's going to return x plus y. You'll notice in there that I don't have curly braces. Curly braces are missing. I don't have the function keyword, but I do have this arrow, right? I also don't have the return keyword. So when you're writing an arrow function, the return is implied. Does that make sense? But for a simple function like this, the return is implied. There are some nuances. Like there's two reasons why this exists. One reason is that it's just shorter, which turns out makes a big difference for code readability for the stuff we're going to do this semester. The code readability difference is so pronounced that we're going to basically just be using this all the semester. This third syntax we'll be almost using exclusively. We will very rarely dive into the other two. Okay? The other thing that this does, in the world of JavaScript, there's a quirky little variable called this. Okay? There's a quirky little variable called this, which behaves completely non-intuitively. I'd say in JavaScript, the way the word this works is not the way that anybody would expect it to work. Okay? And the way the word this works in JavaScript is not the way that anyone would expect it to work. Okay? The way it works in if you were looking at C#, well, this is a reference to the object, the class you're in, right? It's a reference to the object you're in. That's not what this represents in the world of JavaScript. Sometimes it represents that, but most of the time it may or may not be that. Okay? So this is a variable that you can use in some cases to kind of access yourself, sort of. One of the difference about this is if I have a function here with the function keyword, either of those two syntaxes, whether I'm using a function declaration or a function expression, when I get inside of this function, the meaning of this may have changed. So outside here, before I call the function, I may have one value of this. Inside of this function, it may be something completely different. So for instance, if you're working with jQuery or event listeners commonly in the browser, this may refer to the element that triggered the event, is commonly recognized, right? That behavior can be a problem. That can get pretty confusing pretty quickly when you dive in functions nested inside of functions nested inside of function. Every time you go down, oh, well, this changed, and this changed, and this changed. So one of the benefits of this arrow function syntax is it doesn't, what we call it, doesn't rebind this. So if you have an arrow function inside of here, this is still what it was outside. It doesn't change. Use an arrow function inside of there, the meaning of this will not change, which is actually really helpful. Okay? That's one of the reasons why I use this almost exclusively. Because there's a lot of cases this semester that we run into where if this were to change, then that causes you issues. The other way that we can go around kind of avoiding some of those issues is to actually just straight up not use this, to not use the this variable, which actually is the direction that I've started to go down. And I think that for a lot of the stuff that we're going to do this semester, we can just take that route. Let's not use this because it behaves so oddly. But it's worth noting that there's some weird behavior there. Okay? Outside of the this is basically just a shorter syntax. Okay? There's a few things you need to know about this as well, about arrow functions. So when we're talking about something that has two or more parameters, it's basically always going to look like that syntax. Okay? If it only takes one, I can write a function like this. So maybe I have a function x arrow x plus 3. Okay? So this is a function that has one input and returns x plus 3. Everybody good with me there? There's a special exception with arrow functions that only take one parameter. You're allowed to leave off the parentheses. If it takes exactly one parameter, you are allowed to leave off the parentheses. So both of these two are allowed, and they're both equivalent, right? With the parentheses, and without the parentheses. Okay? That exception only occurs, though, for one argument. If you have two arguments or more, you have to include the parentheses. But if you have exactly one, you can leave them out. If you have no arguments, which would be the case here, so if you say no arguments, and I'm going to return 5, this would be a function here that takes no arguments and returns 5. Okay? So no arguments, you need the parentheses. 2 arguments, you need the parentheses. 1, you don't have to have. They're optional for that case. I only mention that because you're probably going to see it at some point in a code example somewhere. Okay. I follow the convention that I just always include the parentheses. In fact, if you're using Prettier to format your code, Prettier will change all of these occurrences without the parentheses to include the parentheses. So there is that shorthand, but I generally don't use it. Okay? So I just want to make you aware of that. Cool. Another thing that's worth mentioning here, so far these examples that I've shown are all examples where I have a very short function, right? I have a short function, it's not doing much. So what's over on the right can easily fit into one line code, which the syntax is amazing when you have that, right? It's amazing to be able to write this. X is x plus 3, and you can write it so brief. But sometimes you're going to find yourself writing functions that are a little bit longer. So let's say I need to do something a little bit more in depth. Let's say I want to do something here, and maybe I say, what would cause it to be longer? what am I looking at? Maybe I say that. Yeah, that's what I'll do. So const is positive, or maybe is valid. So what I can do is I'm going to create that variable, and this is going to take maybe an email address. If I have a longer function that I need to write out, I can use curly braces. So if you have a longer function that you need to write out, you can use curly braces. Unlike when I'm writing things here, like here, without the curly braces, the return is implied. This does not imply a return. Okay, so if you're using curly braces, you do have to remember to include the return. Okay, so let's say we're saying if an email is valid, I might say, well, if the email is, if it's null, then I might return false and say, hey, this is not valid. If my email is empty string, I might say return false again, right? I might want to check some other things. So I might want to say else if the email dot includes an @ sign, then, or it doesn't include an @ sign. So include says, does this substring occur anywhere in there? I would say if it doesn't include an @ sign, then we return false. And then maybe all the way at the end of here, I could say it returns true. So you can still write longer functions. Is the main thing I want you to see. With this arrow syntax, you just need to use curly braces, and then you basically write returns. Cool. That's the one. The main thing that throws people off usually is they forget to write the word return at somewhere in their function. Questions? So a little thing you might see here, you've seen your statements, it's maybe been a while, this is kind of the syntax that we're looking at. So you can say if, blah, 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 do something, else if, and then finally an else will be the hanging case. This sort of syntax we use a lot. Okay. But that's just kind of your reminder. So if we write it this way, only one of these things can happen because the else if only triggers the first previous case. Cool. Okay, so that's kind of the gist in terms of functions. Is there's that arrow syntax, and that's generally the syntax that you're going to see as far as this semester is concerned. Cool. We use a lot more arrow functions and a lot less of the arrow declarations that you would have been using maybe in first semester. Let's talk quickly about strings and string concatenation in particular. So I'm going to make a new file here and call this strings.js. Okay, and let's say I want to build up a message. Okay, so one way I can do this, I could say const message is, I could spell it all out, and I could say, hey, if I've got it all in one, I can put it all in one string. Okay. If I know all of the data that goes into that string, I can just immediately spell it out as one thing. And this is usually, if you can do this, do this. Okay? Sometimes you get into cases where some of these parts are dynamic, where you need variables. So maybe sometimes it starts looking like this. Where I need to start putting things together. Okay? So remember, there's two ways to use the plus sign. The plus sign can mean addition, but it can also mean concatenation. Okay? If I'm dealing with two numbers, I'm adding up two numbers, then that plus sign is going to mean addition. If one or both of those things that I'm adding up is a string, it's going to do concatenation instead. So everybody with me there? You're going to get concatenation instead. And that's important to understand. So if I do this and then log the message, we're going to see it's taken those individual pieces and put them together. There we go. So it's taken my hello plus a blank plus a world, and I smashed all these things together. That's not so interesting because I kind of already had all the pieces and just kind of I could have put them together to begin with. But oftentimes we end up in cases where we don't have some of those. Maybe they're inputs, they're variables from other code that we're working with. So oftentimes you may have something more like console.log, or sorry, const message 2 is equal to hello, and I want to squeeze in there somebody's name. Right, so maybe I need to declare the name. So const name is So oftentimes you have variables that you need to introduce. Okay. You'll notice one thing that's a common gotcha. You'll notice I have a space here at the end of hello before the quote ends, so that space occurs there between the name and the text. Cool. So this is a common way to kind of put strings together. You've already probably seen, right? So using string concatenation. Okay. You can do that. That's one way to do this, solve this kind of problem. Okay. Oftentimes you may need to add in numbers. So I might say, hey, let me have const number is 3.1, and let's make a message that includes that. So I might say message 3 is your number is blah. So I add in the number. And so that's going to not do addition, but it's going to do concatenation, because one of those two things is a string. Console.log message 3. Okay, so far so good.
I have a question.
Yep.
Why is the name scratched out? Strike through?
I
did the same for me.
Because it's a global variable. It's a special variable name. Yeah. There's something else going on there. Cool so far, right? So I can use concatenation to put things together, right? This starts to bite in a few ways. First of all, this here, right, is kind of hard to read, right? There's some difficulty in reading things as you start adding these pieces together, right? As things get longer and more complicated, this can quickly get out of hand. Another kind of gotcha here, which you often want to watch out when you're dealing with numbers. Let's say I take 2 divided by 3 and log that instead. You'll notice that it's writing it out with a bunch of more decimal places, right? So if I'm just concatenating things together like this, I'm not controlling how many decimal places it's going to count as, right? And oftentimes that can mean that different things happen, and so sometimes randomly it's just all of a sudden much longer than it was previously. So pretty much anytime I output numbers to the user, I need to specify how many digits I want it to be rounded to. Make sense? Anybody remember how you specify how many digits to round something to?
That would be too big, right?
ToFixed, yeah. So we use the ToFixed function, and that will tell it how many digits do I want to round it to. So I say number.ToFixed, and so if I say ToFixed 3, that will always round it to 3 digits. So in this case, it's rounding it to 667. Previously, I had 3.1 there. It's still rounded to 3 decimal places. Okay? So that's very helpful. Another thing that's worth noting, anytime you call ToFixed, it also converts it to a string. Okay? So as soon as you call ToFixed, it's no longer a number, it's going to be a string. Okay? Keep that in mind. And which means that if I call ToFixed, I can't then do math on it. Make sense? I can't do math on it because it's already been converted to a string. So what we commonly do to try and ease some of this formatting work is we use something called a template string. So I'm going to say const message 4 is equal to something like this. Now, pay very close attention to the quotes I'm using, right? So single quotes and double quotes, you can use those interchangeably. They just represent a string. If you use this character, right, it looks like a little hash. It's in the top left corner of your keyboard. For me, it's right underneath my escape key. This little apostrophe sort of thing, that declares what's called a template string. Okay, and so a template string works a little bit different. Where possible, if we just have constant things, we're going to use generally single quotes. It's kind of the convention per the Google kind of standards, coding conventions, single quotes over double quotes when you're representing strings. And part of that, the main reason why we're doing that is because commonly we're embedding some HTML inside of our strings. And so in the HTML, we commonly have double quotes already. And so by using single quotes, we avoid needing to escape the double quotes. Cool. So here. So if I want to do what I did above, hello name, the way I write it here is this syntax. So I basically want it to be like this, right? I want to be able to inject a variable into, or an expression into that string. So what we do is we use a $ curly brace and a curly brace at the end. So this is going to basically do the thing that we did with concatenation. So on line 5, line 12 and 5 are the same thing. So message 2, message 4, they're the same ID. So let's log out message 4, just to show. There. So you see it puts it together as hello, Paul. I would strongly advise and strongly ask, anytime you need to put things together, use template strings over using concatenation. Please avoid using string concatenation completely, okay? Because this is going to make your code easier to read, and in some cases it will actually make your code a little bit faster, okay? Everybody good with that? That quirky sort of template string syntax? I can do the same thing with this one. If I want to say your number is message 5, message 5. I'd start it there, pull this out, and so it will look like this. If I needed to put a number in there, I would use the same sort of quotes. Your number is, curly brace, /, curly brace, and then curly brace at the end. So you'll notice I can actually call functions and do calculations within here. So for instance, I could do like 2 plus 3, and it would do all this kind of thing. Cool. Doesn't just have to be variable. It can be any sort of expression. Questions? Save that. So that's a helpful thing to keep in mind in terms of how you format things.
C# can do the same thing, except you have to list out more
Um,
variables at the end.
It's not, it's similar. It's similar in C#, but C# syntax is actually different. It's similar. The way that C# works, if I remember right, this same thing would be a little bit like this in C#. It would be just the single quotes with a $sign at the front. And actually, and then C# does it like this. This is what the equivalent would be in C#. It's similar, yes, but it's not identical. Catch me there? It is similar, but it's not identical. Yeah. Yeah. Okay, so we've talked about strings. We've talked about a few different things. We talked a little bit about if statements. So it's kind of the same syntax that you've seen before. With if statements, you got if else. Remember, you don't have to have an else with your if statements. It can just be else. If you're doing a sequence of if else, I would generally recommend you do include the else at the end as a good habit. Even if you end up putting a comment in there and saying, hey, I'm not going to do anything in the else case, please include the else case. Cool. Okay, so let's talk a little bit about loops. So I'm going to make a new file, loops.js. Okay. How many different kinds of loops are there in JavaScript? How many different kinds of loops are there in JavaScript? 5. There's 5 different kinds of loops. 5 different ways of writing a loop. Pull up the codex symbol here. Right, so on your sheet, you'll see, hey, at the top I'm defining an array called R, ARR, which is a cat, a dog, and a unicorn, right? So it's got 4 elements in it. What I'm showing you is 5 different ways I can use, 5 different loops that I can use to loop over that same array. Okay? So you'll see that there is a while loop, there's a do while loop, there's what's called a counted for loop, a for in, and a for out. Okay? So while is kind of your basic syntax. It's just the only thing that goes in there is true or false, and it loops as long as the condition is true. The thing to remember is while runs 0 or more times, whereas do while runs 1 or more times, right? So if you know you need to do it 1 or more times, that's where we do this. And so that's why you'll see in the second example, I'm wrapping this with an if to check that the length of the array is greater than 0, so I don't try to loop through an array that's empty, okay? Just kind of getting you oriented as far as what we're going to do this semester, you will probably not need to write any of these. You probably will not need to write any whiles or do whiles. Okay? Those we basically won't be. Oftentimes those are referred to as what we say indeterminate loops. The kind of the idea being you use them when you don't know how long the thing is. But for pretty much most of what we're going to do this semester, we'll know how long it is, because we're usually going to be working with an array. Okay? And there may be some exceptions to that, but that will be later on. So these are the three syntaxes. These three versions of for are the ones that you want to get intimately familiar with. Okay. So the first one, this one is a counted loop. Remember that there's three parts to this. So the first part is what we call the initialization. The second is the check expression, and this is the step, right? So we start out by running this first part, and every time we go through the loop, we're going to say, okay, is this true? If it's true, we keep going. If it's false, we stop. And the third part is do this at the end of every iteration. Okay? This is what you've probably seen, and probably the thing you're most interested in. Because you've probably got this one integrated in your head. Okay? This is useful. I'm not saying it isn't useful. In fact, you can write every single loop. Every loop can be written using just this one syntax. Any kind of loop can be written using this counter form, just so we're clear. Right? It is possible to only use that one syntax and forget the other four that exist entirely. That's entirely possible. Okay. So the question you'd ask is, if I can do it all with a for loop, why do I need to know the other ones? Readability. So there's a big difference in terms of readability, and there actually is some, yes, sometimes in terms of optimization as well. Okay, but the big thing is readability. Okay, so the reason that we're going to use these this semester is because there's an awful lot of cases where they make it more readable. Okay, and specifically, so there's two. There's a for in. You'll notice it's const index in array or const item of array, right? So the in keyword versus the of keyword. So if I'm doing a for in, what I get every iteration through the loop is the index or the key. Okay? So I'm going to get, hey, I get index 0, 1, 2, 3, 4, etc. Right? So I get index that way. And so that means if I want to log out the item, right, I need to say r index. Cool? The other way here, I just get the item, and you'll notice I'm logging it directly. Right? I'm not going back and indexing into the array. Most of the time, this is the syntax you actually want. Most of the time, this for of is going to be the easiest syntax to use and going to result in the most readable code. Cool? Because, hey, I just have the item. One thing to notice on both of those, right? So with this for, the counted for, notice I had to use the keyword let. I'm forced to use the keyword let because this I variable has to change over time. But notice with both the for in and the for of, I can use the const keyword. Does everybody see that? Because what happens basically every time you go through an iteration of the loop, it's creating a new variable. So that variable is never reassigned, it's a new variable every time. So it can be const. And remember I said you want to do const as much as you can, right? You want to have as many consts as possible. And because it avoids a lot of issues, a lot of errors. And can actually sometimes make you code faster too. So that's that. Okay? So keep those different syntaxes, those different loop syntaxes in mind. In C#, you may have run into the for each statement sort of thing, right? These are both kind of for eaches, right? It's just one is a for each over the index, and one is a for each over the items. Okay. Generally, the for of is the one we typically think of as a for each. Okay? I would suggest that you want to get most used to for of. Will turn out to be the most useful for us. Okay, let's start a little bit about data types. So you'll see on the first sheet of that handout that there's a few different data types listed. Okay, so those are all the data types that exist in JavaScript. Okay, those are all the basic data types. I would strongly ask that you memorize this list. It's well worth your time. Memorize that list of data types. It'll help you with dealing with error handling and all sorts of other weird things you're going to run into. Okay? if you know all those types. So the first data type in JavaScript is something called undefined. Undefined, as we saw, means that there's no value, right? So that happens if you access a property that hasn't been set. You get that if you access an array index that hasn't been set. You can also get that if you have a variable that you've declared but haven't assigned, right? So for instance, if I say another way to get undefined is if I say let x, right? That variable will now be undefined because I haven't given it a value. The value of that variable will be undefined. Make sense? The common assumption, if you're not too familiar with JavaScript, you might look at that and say, well, it should be null. No, it's undefined. Okay. So that's one way you can get undefined as well. Boolean's pretty easy, true or false. Numbers, unlike other languages, JavaScript has the quirk that there's only one number type, basically. There's only one number type. You may remember in C# you had like a byte, a short, a integer, and a long, and you also had float and double, right? So in JavaScript, the only number type you get is double. It's a 64-bit floating point number. That's it. So you have to remember that whenever you're dealing with calculations, you're always dealing with floating point numbers. There are some cases in JavaScript where the optimizer will decide to use an integer type instead, but it doesn't really behave necessarily the way you might imagine, right? And you can't really rely on that behavior, generally speaking, okay? But there are some cases internally where it might switch over to an integer type for efficiency's sake. But generally speaking, you can just assume that it's a floating point number. Cool? That's one thing you have to keep in mind. So for instance, if I want to do, in C#, if I wanted to divide integers, right, normally it would round down, right? So if I were taking C# and I said 5 divided by 4, what was the answer in C#? 1. It was 1, right? It would round down. But if you do the same calculation in JavaScript, 5 divided by 4 is going to give you 1.25 because it's always a floating point number. Got it? So you're getting different answers between JavaScript and C# because of those things. Next up, you have a new type to JavaScript called a big integer. And a big integer is an arbitrarily sized integer. That means it doesn't have an upper bound. But it's strictly limited to it has to be an integer, which actually in itself is kind of a benefit. If you do need an integer, you can sometimes use that. It's worth noting that the big int does take a little bit of extra space because it's basically an array. It's an array of digits. Okay? The way you specify that, as you can kind of see here, if I want to specify a big integer, I just put the character n at the end. So this would be a number type. N at the end makes it a big integer type. Big integer we won't play around too much with. We're mostly going to focus on numbers, but it is available there. Strings, you can define that, as you're familiar, as a sequence of characters, and you can define that using the single quotes. You can define that using double quotes, or you can define that using a template string. All three of those will end up giving you a string. It's worth noting there's one notable thing missing. There's not a single char type. So you remember in C# you have a char type and a string type, right? So a string is an array of characters, and a char is a single character. There's no single character type in JavaScript. It doesn't exist. There's only strings. Cool? Kind of a weird exception, but there's no char type. Next up, we have objects, and that actually includes null. Null is considered an object. Objects are considered objects, as well as arrays are considered objects. And I can actually prove this to you using a special tool, special operator in JavaScript. So if I go back into here, I'm just going to type in node to get into the interpretive mode there. And so if I say, let me say exit and get out of here. There. So node, there we go. So there's a type of operator in JavaScript, and that tells you the type of something. So for instance, if I say type of null, you see it returns a string, so type of always returns a string, and it says type of null is object, right? If I say what's the type of an actual object, anything with curly brace, also object. Type of array is an object. Okay, there's actually no array type in JavaScript, which is weird, which is very, very weird. But there is no array type in JavaScript. Arrays are also objects. If I look at, let's get the type of a function. So maybe I define a little array, a little function here, an arrow function. Type of that is a function. So there's a function type, which is distinct, and there's an object type, which includes null, objects, and arrays. Okay? That's a common gotcha. Common gotcha is that you'd think, hey, the type of an array is an array. Nope. Or the type of null is you would expect it to be null. But no, the type of null is object. Because null represents the absence of an object. Basically the way you think of that. It represents the absence of an object being there. Okay? So those are the basic types that we have in JavaScript. Okay? Questions? So those are all the types you have to work with. There is technically a symbol type in JavaScript, but we're not going to do anything with that, so you don't even know that it need any sense. Cool? Okay, let's take a break, because I've been talking for a bit. Call it 15 minutes. Let's come back at 2:45. I asked a few people this already, but is everybody kind of feel like they're getting back up to speed with JavaScript? It's coming back to you, kind of the different pieces and nuances in terms of the language. Any questions over the stuff we've covered so far? Yeah.
Earlier you think that constant of the variables aren't constant.
Yes.
That kind of throws me off. That constant is your own thing, but a constant word, it kind of implies a constant anyway.
Yeah, it's not really constant. Yeah. There's a strict idea of constant, which actually kind of dates back to C and C++ actually had an idea of constant, which was literally constant. We don't really have that in modern programming, like most modern programming languages. And part of that is because issues specifically we had with C and C++, that it was such a big deal, it was such a problem that const was actually constant, that we, in C++, there is something called a const cast, where you can take something that's constant and make it not constant, which shouldn't be, right?
So eventually we'll reach the strategy to cut constant entirely to keep constant.
Yeah, so we redefined what that means, and namely we redefined it as not being reassigned. I think that the word that Java uses, which is final, the final keyword makes a lot more sense. I wish that that's the word that we've gone with, but it was a little bit too long, and it was a little bit Java specifically. So that's a little bit of that history. Okay, so last thing we talked about is a little bit of what the data types are that are variable. And remember, you can use the type of operator to find out what type something is, what type of variable is. But you do have to watch that there's some nuances, like it doesn't tell you that an array is actually an array. The next thing I want to talk about, the next concept, is something called truthy and falsy. Okay, and I think I mentioned this. I may have mentioned this if you've worked with me in the first semester class or over the summer, but I know this is not in the textbook, right? And so this may be a completely new concept to most of you. But it's actually really important to understand, and it makes a lot of things a lot simpler once it can make your code a lot simpler once you understand it. Okay? It's something we're going to use a lot this semester. It comes up a lot. So, over on the way this works is every value in JavaScript, it falls into one of two buckets, falsy or truthy. Okay? If it's truthy, then it is treated as true. If it's falsy, it's treated as false. Are you with me there? So it's either treated as false or treated as true. Okay? And so things that obviously fit in these buckets is true is definitely truthy, false is definitely falsy. That makes sense, right? Okay? So I want to kind of divvy up and divide every possible value into one of these two buckets. I can treat it as true or I can treat it as false. Okay? So that's kind of clear. Does that make sense? True is truthy, false is falsy. What about 0? Where would you put that in the bucket? Well, false is basically literally 0. It's actually how we represent it in the computer. So we say, well, 0 should be falsy. So I stick 0 over in this bucket. And specifically, I'm going to stick 0, -0, and this over here as well. Because when we're dealing with floating point numbers, there's both a positive and a -0. The reason that comes up is because 0 actually represents a very, very small number. It doesn't actually represent 0. There is no 0 with floating point numbers. It's just a really small number. Okay? So you can have a really small positive number, a really small negative number, and then you can have big integer 0. Remember that n represents big integer. So those all fit in there. And so then what we say is every other number value that's not 0 is truthy. Does that make sense? Everything else. So for instance, 1 is not 0, so 1 fits over here. -1 is also not 0, so it fits over there. 2, 3, etc. Right? Anything that's not 0, whether it be positive or negative, fits over on that truthy side. Cool? Next up, we have some special values. So there's a special thing when we're dealing with floating point numbers. You can get what's called an NaN, or not a number. Okay? So NaN, you write it with an uppercase N on both sides and a lowercase a, is not a number. Okay. Although technically it's also it is considered a number, but that's what that is. Okay? Not a number is basically an error code. You can think about doing calculations on your calculator, and sometimes it gives you an error, right? It says you can't do that, right? So that's what number represents. It represents an error in your calculation. Very clear with that? Not a number represents an error with your calculation. And so that can come up in a broad variety of cases. So for instance, one of the cases where that runs into, if you say 0 divided by 0, That's not a defined, there's not a defined answer to that. In fact, there's ways to concoct and ways for that to be any number possible. So this is a case that 0 divided by 0 is not a number. If you do that calculation, that's what you'll get at. Okay? It's also worth noting that not a number is not a signal value. It's an error code. Okay, so not a number is an error code. You typically don't see the error code in your programming language. But what that means is there's actually more than one not a number value. Does that make sense? There's more than one not a number value. So because there's more than one not a number value, we can't do things like this. If you say x equals not a number, there's a problem here because not a number is not just one value. So I can't do this. I can't determine if something's not a number by comparing it to none. Because there's not just one not a number value. There are many. And so this 0 divided by 0 gives us one case. Another way that you commonly get not a number would be like parse float ABC. That'll give me a not a number as well. Okay. Because it tries to parse the string and says, well, I can't come up with a number for it. Cool. So you can get not a number from various kinds of calculations. This is not the 0 divided by 0 is not the only case, but you also get it from parsing. Okay? So not a number we generally treat as an error. That's a problem. So all the not a numbers, we toss them over in this falsy bucket. We're going to treat any not a numbers as an error, as falsy. Cool? Everybody there with me? So non numbers over here in the falsy bucket, zeros over there, every other number is over here. What about strings, right? Okay. What would you maybe consider what would be maybe commonly an error when you're dealing with strings? Commonly indicates maybe the user hasn't typed anything in. Empty string. So we're going to also put over here, we're going to put any empty string is going to go full into this bucket. You got an empty string, that's considered falsy. Cool? One of the reasons we do that is then that allows us to do things where we can say, okay, the values over here means the user hasn't typed anything in. And the values over here means the user has typed something in. So we say, okay, empty string, we're going to call that falsy. Any other string, we're going to call truthy. So for instance, ABC, right, is not empty string, so it would be truthy. Okay? Or if you have a string that is 3 spaces, that's truthy as well. Right? That's truthy as well because it's not no characters. Make sense? It's only considered falsy if it's exactly 0 characters. Okay? So it'd be a bunch of white spaces, but it feels like that's okay. The other things that we look at is there's 2 special values. There's null and there's undefined. Both of those represent an absence of a value just kind of in different ways, right? So those are both considered falsy, right? We're kind of treating these as typically if you're seeing these, it may be like the user hasn't typed anything in a lot of these cases, okay? So these fall in the falsy bucket, and I think that's all of them. So I caught false, 0, null, undefined, and nan. Right. So these are all defined as falsy. Everything else, anything that isn't these things, is truthy. That's the part to remember. So truthy is a very big space, right? There's a lot of things that are truthy. There's a very narrow number of things that are considered falsy. Everybody good with me there? The reason that this is relevant is it allows us to write some very short, brief code to check for a lot of different things. Okay, a lot of things that otherwise would be much more complicated to write become much simpler if we understand that this is a thing. Okay, so let's look at that. So this often comes up when we're doing things like validation. It can come up in a lot of different places, but it comes up commonly with validation. So let's make a new file here. I'm going to call this truthy, truthy.js. So let's say we have the user typing something in, and maybe we want them to type in a number. Or actually, let's just start with a string. So let's say I want to say, type in your first name. So we're going to say first name, okay, is Paul. And so what I want to do is I want to do one thing if you did type a name in, and I want to do something else if you didn't type anything in. So first name, else, so console.log, there. I'm going to just stick with log on both of those. So I'm going to say node truthy .js and run that, right? So I entered a name, right? We're going to talk about how you get input from the console, but we'll talk about that in a bit. So I can say if I entered a name, this is valid. If I didn't enter a name, that's invalid. That's kind of what I want to get to, right? And this is part of the benefit of writing it with this understanding of what's truthy and what's falsy, is it allows us to write code like this. Cool? This is what we're trying to get to. And we can test it a little bit more. So let's say I leave it blank and I say empty string, right? We can try to run this again and we'll see that that comes out invalid like I want it to. If I put in null, that will also come out as invalid. If I leave it as undefined, which use a let here, then it's also going to come out invalid. Cool. So it's covering all of those common cases of undefined and null and empty string for us. Okay. If I was going to write this without using the truthy situation, this is what my error would. This is kind of what my thing would look like. I need to say, well, if it's not equal to undefined and first name is not equal to null and first name is not equal to empty string. If I don't take advantage of that code, of this truthy falsy idea, that's the code I have to write to do the very same thing. Do you see the problem? Do you see the reason why we care?
Yeah, we did that.
Yeah. So if you don't use truthy falsy, you find yourself writing this very complicated validation logic, whereas you would be writing something much simpler if you just take advantage of that. So that's why we're doing it, is it allows us to write this instead of that. It's a way to write simpler code in a lot of cases. A lot of times what entry-level developers or newbie developers end up doing is oftentimes they'll start writing this first one out, and they'll just say, well, let's just check that the first name is not empty string. Well, but you forgot to check for null and undefined, right? And so now null and undefined is if I just say first name is not empty string, null and undefined is treated as valid, and that's a problem, right? So it makes sure that we're catching all those cases. Let's think about this now with a number, right? So number is a little bit of a different story. Let's say I say let num is 3.5, right? So traditionally, the way that you would have had to check how to do this, right, would have been, hey, let's write a bunch of conditions and let's specifically mark out what could be wrong. So let's say, hey, well, number can't be 0. All right, well, it can't be 0, and maybe the number can't be null, and the number can't be undefined, and it can't be nan. So is nan is false for num. Right? So that's traditionally how you would kind of have to write and check all of these different cases. Does that make sense? Okay. So what we're trying to do is replace that with something simpler, which is why we're writing it this way instead. I just say if there's a number. Rather than checking for all of these individual pieces separately, I just say, is it truthy or false? If it's truthy, we're good. It's valid. Now, commonly, one of the things you run into, remember that truthy, that negative numbers are considered truthy, right? Negative numbers are considered truthy. So if I want to say that this is has to be not just a number, it has to be a positive number, then I do have to add an additional clause. So if I want to say it has to be a positive number, then I would say it has to be a number and it has to be a number greater than 0. Does that make sense? If you need a positive number, that's the way you're going to write it. But that's still pretty easy, right? Everybody on board with that? Still fairly simple. Now, there's one gotcha here, namely that remember 0 is treated as falsy. Sometimes you're okay with 0, right? Sometimes 0 is a valid value. Everybody with me there? Sometimes this would say it has to be strictly greater than 0. Sometimes I want it to be possibly equal to 0. And so the way I would write that, this would be greater strictly greater than 0. I might want to say 0 or greater. What kind of if statement would I write in that case? If I want to say it has to be 0 or greater, what if 0 is legal? What would you write here? Okay, so you say number and that, right? Okay, well, let's test that. Let's see if that works. So if I try to put in, let's say I try to put in, let me just make another number variable here. I'm going to call this num2. So num2, Obviously 0 will work. Okay. I can try negative. I know negatives are going to fail there. Null. Cool. Yeah, and I think you're right. I think that one does work.
Multi valid for some reason.
Oh, did it?
Yep.
Oh, right. Null is valid. So the weird case with null is that with JavaScript, remember that it's, as I said, it's dynamically typed. One of the things that it does with these comparisons, if the two types are different, it will try to convert them to be the same type. So when you actually say null is greater than or equal to 0, what it does is say, well, I've got object and I've got a 0. And it actually what it ends up doing is converting a null to a 0. And so it says 0 is equal to 0. That's what came out. So what I would do is I still need to use this idea of truthy and falsy. So what I would do instead is I would say something like this: num is equal to 0, or let's see if this works. So if I do something like that, I don't think this one's still going to work, right? So this one still complains, right? Same issue. In JavaScript, there is a triple equals. Did I save that? Why did that one still run? Let me check something. So num. Okay. So if I do null equals 0, well, wait a second. So that comes out false. Both of those come out false. So why does null? That's weird. So if equals, both of these equals come out as false, why does... Oh, maybe? Nope. I don't know why this one comes out true. That's odd.
What do I know?
My guess is that it's somehow converting it. I just don't know what type it's up converting in null to. That's all. What happens if I do... That is very weird. That's something that might require some research. Because that's not something I've noticed before.
Me neither.
So what my instinct would be to say that it should be let's say I do this. So null comes out invalid that way.
And that's because of first unknown two.
Yeah. So we say that num2 is true or is exactly equal to 0, and it's greater than or equal to 0. That would be my way to cover that. So in there, you've kind of seen that there's a triple bar and there's a double bar, right? So everybody remember? Does anybody remember what the difference is? What's the difference between a double equals and a triple equals?
The third one enforces like the same data type.
Yep, enforces the same data type, and the double one does not. So specifically, if I do this, let me go into Node, and if I say the string 1 equals 1, that's true, right? It converts them both to strings and then says they're equal. But if I say 1, the string, triple bar 1, it says no, they're not equal because they're different data types. Cool? So double equals, same thing, there's a not equals, and there's a not equals, which is the opposites. So I can say that, you know, if I'm looking at those strings, I could say 1 not equal 1, and that would be true. So you can flip both of those things. Cool? That's one kind of gotcha with double equals and in there is it does automatically allow for conversions. So sometimes you have to use triple equals to avoid the conversion, which is kind of what I'm trying to do here. I'm trying to avoid it converting to any other type other than number and passing that as true. Okay, so does that make sense in terms of truthy, falsy? It's going to make your code a lot easier for the most part, unless you need a 0. If 0 is true, then it gets a little bit more fishy. But as long as you don't have those cases, it's usually pretty simple. So a lot of times we're dealing with strings, and so easy fix. Cool. So I expect to see that in your several of your programs if you're checking for validity. Okay. What was next on my list? Okay, so that dovetails into another thing I want to talk about real briefly, which is how does that fit in with some of the logical operators, right? So if I create a new file, logical.js, it kind of dovetails into a few things here. So remember the logical operators. There's a few different operators that we've got in JavaScript. Namely, we've got a not sign, we've got ands, and we've got ors, right? So not is a single exclamation mark, and ampersand is and the double bar is or. Okay? There's some very interesting things that we get because of this sort of truthy falsy behavior and how it behaves in combination with these operators. Okay? So one of the things that we see, if I take some of these things, and maybe I can just do that on the shell. So if I say take not null, right, it gives me true. because if you take a truthy or falsy value, not actually forces it into truth or false. It forces a conversion to true or false. Which the outcome of that has a kind of interesting thing it does. So if I do not, null, okay, not takes the value, inverts it, not inverts it again. So if you do not, that will take whatever value it is and convert it to true or false. Does that make sense? Not will convert something to a Boolean. This is how we do that. If we do, for whatever reason, need to convert it from the value that it is, we can convert that. And I can do the same kind of thing with like empty string. I can say not empty string, get there. If I want to say, hey, not Paul, I'm going to get true because that value is truthy. That's a very helpful trick, is you can use double not to convert things into Booleans. Okay? It also means that you can use single nots with like first name to check for things. Because usually what we want to do is say, hey, you didn't enter a value. So I might say not first name. If not first name, then there's an error. Make sense? So we commonly use those things together. And has an interesting sort of working as well. So remember that there's a kind of shortcutting with ands and ors, right? If one thing comes, if you're working with an and, the first thing that comes out false means, well, the whole thing's false. So it doesn't go through the rest of the calculation. So one interesting thing I can do is I can say null and 5, right? The first thing's falsy, so it goes ahead and aborts. But notice the output of null and 5. It's not false, it's null. Do you see that? I can flip this around and say 5 and null. So it says, okay, well this thing's creepy, go on to the next thing. So I can kind of use this to do some various things. And usually it looks like maybe 3 and 5. Oop. 3 and 5 will evaluate to 5 because the first thing was truthy. Okay. So if the first thing is falsy, we get that. If the first thing is truthy, then we get the second thing. It's weird. The way we use this is we do, specifically with React, we use this for things like conditional rendering. So we're going to say, hey, if, I had an example I written down here. Yeah. So if logged in, then show the like log out button. And so then this will only show the log out button if logged in is truthy. Otherwise it won't show anything. It's kind of a shorthand for a ternary almost, right? The way you could write this with the ternary, you would say, hey, the equivalent here would be if logged in is truthy, then we do that, otherwise null. So shorthand for a ternary, basically, is one way to think about it. Yes. Yes.
Include the opposite case.
Huh?
False, so you can only get false and true result.
Yeah. So this is kind of where that comes in. Is we might do a shorthand for that. Or also has kind of a similar behavior. And so we commonly do that with things like, hey, I need to get a port number. So say const port is process.env.port or 3000. So the way this works out is if this thing here, if this expression comes out as truthy, we use that value. Otherwise, we default to 3000. So specifically here, we're saying, is there an environment variable set called port? If it's set to a non-zero value, we're going to go ahead and use that port to host our server. Otherwise, we're going to host it on port 3000. We haven't set that environment variable. So that's really, really useful. Okay? For setting default values. You say, if you set a value, use it. Otherwise, use this other value. Cool? That's kind of exploiting this truth and falsity behavior as well. Is it worked with ands and ors and nots in kind of an interesting sort of way. Questions? Okay. Last thing in here. I'm going to go back to my functions. So specifically on this one, let me actually make a new file here. I'm going to call this jsdoc.js. So when I have named functions like this, a common thing we want to do is add some documentation to them. And the nice thing about kind of adding this documentation is it also helps our IntelliSense. So we'll give the IntelliSense some information about what data types certain things should be and what the names of the fields are, etc., what the function does. So when you have a named function, what we can do is add something called JSDoc. Okay? And in fact, if I just start typing it, /*, you'll see it already, and hit enter, it already starts filling some of this stuff in for me. Okay. So we can do a few things with this JSDoc. Okay. You'll notice it kind of starts with 2 stars, ends with this. We've got a star for every line. Top of this, we generally say what the function does. So here we might say adds 2 numbers. And I can actually do something interesting here because I can say that this needs to be a number. I can say that we would expect x and y to be numbers. And I can also say that it returns a number. And I could add a comment in there. I could say this is x plus y. Or the sum. What? Yeah. So it's kind of a comment. So this does 2 things. A, this you can use to actually generate some documentation. You actually can use this to generate a website of documentation. We're not going to really do that. The reason that's still useful is because it will give your IntelliSense that indication that x and y should be a number. It now knows what data types you're expecting for the parameters. Make sense? Because JavaScript's not strict. JavaScript will let you pass this function any data types you want. I could pass 2 strings to this, and it will concatenate instead of adding it. Right? So that can be helpful from a documentation standpoint. I just want to point that. Cool.
So that doesn't enforce anything?
It doesn't force anything, but it will at least give you signals when you're doing something wrong. Make sense? Yeah, I can do that. So let's say I do a sum, 3 and 5, that's all good. Sum, you'll notice as I'm writing it, actually that's interesting. It hasn't actually picked it up yet. It still says any there. So here it says number.
Oh yeah, I have two options. Press the up and down there.
Yeah. So it doesn't really prevent you from doing that, but it can help with the documentation sometime.
Okay.
It doesn't do much. It doesn't actually block you from doing those things. So for instance, I can do a console log on these two. Node.js doc. Yes. And it still allows that to happen. So the first one gets A, and the second one gets a B. But sometimes it can help a little bit. Obviously, it's ability to help. Okay. So that's that. So kind of getting back into the world of Node. There's one kind of fundamental concept you need to understand. There is synchronous code and there is asynchronous code. Okay, this is a new piece. Okay, this is not something we talked about this summer. With kind of modern processing, this is a really important distinction. So more than likely, most of the code that you've written in the past has been synchronous code. Okay? Synchronous code is code that runs strictly from the top to bottom. You tell it to do command A, and then command B, and then command C, and it never runs it out of that order. Right? So you say, hey, I want a variable x. X is 3, y is 2, z is x plus 1. Right? It has to run it from top to bottom. Right? That's kind of traditional synchronous code. Okay? That's what we're used to doing. And so the problem, this is all fine when you're doing simple things like that, but then it's a problem when you want to say, hey, I want to read the file, and your program is blocked while it's reading that file. Say, hey, I can't do any of this code yet until that file is finished reading. And so my program's stuck, can't do anything. User can't use the program, it's just sitting there, idling, while it's reading that file. With small files, a fast file system, that's pretty quick. You want to read a gig of data? Whole nother story, right? And so a lot of stuff that we do in the world of web applications specifically includes a database or other web services. And those things have time. Going over the network and going to your database, going to the file system, all of that takes time, a noticeable amount of time, oftentimes. So we have to account for that and really make our code work well. Okay. So traditionally, one of the common sort of traditionally we've always been writing, we've really been writing synchronous code, and we've done this in web development for years. There's kind of an analogy out there. You can kind of think of it as like a restaurant to kind of get a picture of what that means. So in a restaurant, you've got the kitchen, right? So you got the kitchen where the food is cooked. And then out here you have some tables where your customers are, right? So your customers are sitting at tables, they want to order some food, and then they want to eat it, right? Well, you got somebody here in the middle. So there's somebody here sitting at the table. There's somebody out here, come to all the tables. Probably know them as your server, right? Or your waiter. Okay, so your waiter's coming around, trying to serve all these people, and take their orders to the kitchen so that the food can be made, right? It's kind of a normal restaurant flow. So your waiter comes to your table, asks you for your order, takes the order to the kitchen, and then eventually he'll come back and give you your food, right? What does the waiter normally do during that process of when he's delivered your order to the kitchen? Huh? To help somebody else, right? So maybe while that's happening, he goes over here to some other customer, some other guest, and gets their order and takes it or refills their drinks. They're usually busy doing all these other things while the food is being made, right? That's what we want, okay? Now, what traditionally has happened with synchronous coding, actually what happens is the waiter comes to your table, he goes and takes the he goes to take the order to the kitchen, and then he goes on a smoke break. Literally does nothing until the kitchen is done with the food. And then he comes back. And then he comes back, he delivers the food, and the same process repeats. So all this meantime, these other people that want to make orders and want to get their drinks refilled, they can't do that because this one guy is waiting on his steak to be cooked. You see the problem, right? It turns out to be really wasteful. So that's kind of the model. So the way to kind of explain this, how this works in servers, you can think of the guests, your customers, as the people that are using your system, right? So those are the people that are coming in and they're asking for web pages and images and other sort of things. Or maybe they're posting forms and trying to post tweets or like posts or whatever it may be, right? Make comments, all these kind of things. That's what your guests are doing, right? They're sending you data and asking for data, okay? And so your server, the application that we're building, has to take all those requests, deal with them, process them, and usually contact the database and either get data from the database or change data in the database, right? So this is basically your database is up here. Database is up here. Your server's here. This is what we're building in Node. And so then down here you have your actual users. Or more specifically, this is where the browser is, right? So your browser is kind of your user, your client, okay? So traditionally we've said, okay, anytime you make something happen, all of these requests to the database are blocking requests. Make a request to the database, that whole thread, stopped. Can't do anything until the database request is completely done. And that's not necessarily, that's something that's not NoSQL or SQL specifically. That's any kind of database request, any sort of network request we made. That's a synchronous operation. Okay. So you see the problem, right? We want to be more efficient about that. So what we historically did, we said, well, that's a problem, and I don't have a way around it because all of the APIs are synchronous. They're all blocking. So I can't. That waiter just has to sit around and do nothing. I'm stuck. So what we did to work around that is we hired more waiters. We had more waiters working on requests. So one waiter would take in this first guy's request, go and wait at the kitchen. Next guy would take the next person's request, wait at the kitchen. Next guy would take this guy's request, wait at the kitchen. Next guy would take this, wait at the kitchen. And so now you have a bunch of threads that are just sitting around wasting resources and not doing anything. And you've got more hardware that you have to throw at this thing to have enough hardware to meet all your customers. See the problem? It works, we made it work, but it's kind of wasteful, and there's a limit to how well it can scale, right? And if you just think about the waiter example, if it takes you 30 minutes for the food to be cooked, well, that whole 30-minute window is a window where that person could be doing a lot of work. Could be refilling a lot of drinks and answering a lot more customers if he wasn't waiting around for that 30 minutes. Okay. For us, we're not talking about 30 minutes of him waiting for this. We're talking usually about seconds, right? Talking about 10 seconds. You know, hey, maybe this process just takes 10 seconds to do the database query and get the database back. But that's still 10 seconds where we could be handling a bunch more other customers, okay? So that's what we want to be able to do, is we want our servers and we want our waiters, basically, to be able to handle more customers at the same time. And so that's where we get into doing something called asynchronous coding. And that's allowed us to scale these servers that might only be able to handle, you know, maybe you set up a single server that can handle single digits or maybe 20 users at most kind of connected at once, up to 10 or 100 times more customers all concurrently connected. It's huge. It's huge. It's huge feeling. Say 10 to 100 times more customers just on that single piece of hardware. Much better utilization of our resources. Okay? So we really, really, really want to write our servers in a way where we're using as much asynchronous code as possible. Right? So again, asynchronous means that the waiter can be doing things while those long-running tasks like cooking food are happening. Right? He's not stuck. He doesn't have to go out and take a smoke break. Okay? Which means we can hire fewer waiters, and those fewer waiters can do all the work. Cool? Because they're doing more things. They're doing less smoke breaks. Okay. So traditionally, if we were working with synchronous, what this would look like is I would say something like this. So I'd say, hey, I've got const file name is something like students.csv. Right? So I want to read the student CSV file. CSV file is basically like a spreadsheet. So I say, okay, I want to read that file. Const file. Next thing I do is say, well, let's read that file. So read file name. And then maybe I can say, hey, process the file or parse it in some way. So I read the whole file in, I parse the whole CSV, and then console.log okay. Log out first student that we read in file. Okay. So reading the file takes some time, parsing it takes some time too, right? But I'm having to kind of do these things in order. That's our traditional sort of synchronous workflow with this. Okay? Yeah, the problem is I can't do anything in between. And that takes a good amount of time. So what I want to be able to do is do that asynchronously. So there's 3 different ways to do things asynchronously in JavaScript. One is through callbacks. Okay. Take a note of this. There's 3 ways. So callbacks, promises, and async await. Okay. There's 3 different ways to write asynchronous code in JavaScript. You can write it with callbacks, promises, or async await. Okay. All 3 of these work. And hands down, the easiest one to work with is async await. Okay? Hands down, async await is the best of the three. If you can use async await, use async await. Okay? The problem with async await is it takes a little bit of building up to get there. Okay? Because behind the scenes, async await actually uses promises. It's a shorter version of working with promises. And promises is kind of a wrapper around callbacks. So promises based on callbacks, async await is based on promises. So if you're using this, you actually have those things going on behind the scenes, even if they're not necessarily obvious. Okay? So you do need to understand all three of those for that reason. Also because some of the different APIs that exist in Node will require you to use, sometimes you'll have to use callbacks, sometimes you'll have to use promises, and sometimes you'll have to use async await. Unfortunately, you can't do it just knowing one or the other. Okay? Everybody kind of clear there? Okay. So let's talk about how we do this with callbacks first. So traditionally, here we just say line after line, you go from top to bottom, and that's it. With asynchronous code, because we're kind of end up doing things out of order, we have to kind of be aware of that. Anytime you're doing something asynchronous, you're potentially running the code not from top to bottom. Okay? So with callbacks, what this changes to would be something like this. Const file name, same thing. But what changes down here is we say read file. Okay. And notice I'm not putting equal in there because I can't. So I say read file, file name. And when I call this function, right, it's not going to wait to run the next line of code until the file has been read. It's not going to wait to write the next line of code before the file's been read. So what I need to do is I pass in what's called a callback function, which takes two arguments. It takes an error and we'll call it my file. And so I say, okay, go read the file. Here's the file I want you to read. Call me back when you're done. Make sense? It says call me back when you're done. And so it's done reading the file, it's going to call this callback function, where we get the name. So that callback function takes two arguments, an error and a file, right? If everything goes all good, there won't be an error there, and there'll be a file. If something goes wrong, we'll get an error and no file. Okay? So what you need to do is always check first if something's gone wrong. Right? If you're using callbacks, you always have to check first if there was an error. You can't do anything else until you've determined that there's an error. Which is why we follow this convention. With callbacks, we always pass the error as the first argument, so you can't accidentally, you're less likely to skip it and forget that it's there. So we say if error, then I may need to do something. So for instance, here I might say console dot error and log that error. Okay. So if something goes wrong, we'll log that. Okay? If things don't go wrong, all right, then I can actually go through with processing the file. Okay? More than likely, I'm going to find that this takes some time. Let's call it another asynchronous operation. So we're going to say, okay, I also want to parse the file. So parse CSV. I'm going to give it that file, and I'll give it another callback. So, because something could go wrong with parsing it. Maybe it's not actually a CSV file. And if it does, If it does come back, we'll get students. Okay. And so then again, I've got to check, is there an error? If error, we've got to log the error. And then finally down here, we can say, if there's no error, console.log students 0. And we close this out. Here's that. So with callbacks, those two are equivalent. Kind of weird. If inherently, if right off the bat that looks ugly, that's okay. If that looks like it's really messy, that is okay. That is the same gut reaction that everybody has. Is everybody good with that? So the idea is that I call the read file function, and later it calls this function. Okay, and then inside of this function, I call parse CSV, which then later calls this second callback. Okay. So this is the synchronous version. That is the asynchronous version of callbacks. Questions? It's worth noting in the first one I forgot to even deal with exceptions. I forgot to do errors. But that would have been a front patch. So if I was going to check for errors, what it would look like is this. Catch the error if either goes through an exception, console.error. That's how the equivalent error handling would have looked in the synchronous code. Right? So try catch kind of works with synchronous code. You'll notice that I've kind of got to use these if statements when I'm using callbacks. Everybody see that? Which is another function. Okay? One of the things that people forget when you're dealing with asynchronous code, if you have an asynchronous operation, every asynchronous operation is one big thing. If you're dealing with something that takes long enough for it to succeed, it's also plenty of time in there for it to fail. Make sense? If you're reading a file, yeah, it could fail midway. So we always have to catch errors in the, we always have to think about the error. Okay? Right. Questions? Yes? Does that make sense? Can you see how the code's not really maybe running from top to bottom anymore? Sort of. I've intentionally written it in a way so it looks like it's going from top to bottom, even though it's not really going from top to bottom. Because I've got a function that calls function, that calls function, that calls function. It's actually skipping back and forth. Okay. So this has traditionally been the only option. This used to be the only option we had in JavaScript. In fact, in a lot of languages, this is still the only option. Java, specifically dealing with Android, Java still only has this solution. They haven't gotten to any of the other solutions. C# does have async await, actually. It has something, it has tasks which are similar to promises, and it has async await. But Java in particular, this is still the only solution. Okay. So, given all of that, is anybody interested in seeing a shorter version? I hope so. Yeah.
I'm very interested in that short version.
Okay. So let's talk about promises. So a promise in particular is an object. A promise is an object, and it's basically, one way to think about it is it's like a deferred value. You're saying it's a promise for later. I'll give you the value later. I won't give you the value yet, but here's a promise that you will eventually get it. Okay? So that promise ends up starting in two different ways. So it starts out, when you create the promise, it's unresolved. And then eventually, it will become resolved. And so, namely, it will be either, what are the terms? I need to look at this. So promise, one is rejected, and the other one is not coming to mind. MDN promise. Oh, that's one thing. So pending, fulfilled, and rejected. Yeah. So it starts out in pending. So it's a promise starts out pending. We don't know what the answer is going to be yet. And then either becomes fulfilled or it becomes rejected. Yeah. And I think, yeah. So we generally call it resolved and rejected. I can't remember what verbs we use. Okay. So the problem can either be resolved or it can be rejected. Rejected means that whatever you told it to do, it failed. There's an error. Something went wrong. Okay? Resolved means we succeeded, and here's your answer. Right? So you can kind of think about like the callback, right, idea of when the promise is resolved, it will call you back and tell you that it's resolved or it's been rejected when it's finished. Okay? So, one thing to note, so far we've had two versions of refile. I've had a synchronous version of refile and a version of refile that takes a callback. Okay? Now I'm going to have a different version of refile that returns a promise. Okay? So if I can make the assumption that refile returns a promise, then here's how it looks. I start out with refile, file name. Okay? I don't pass it a callback. Okay? It's going to return a promise. Okay? Notice I'm still not saving it necessarily to a variable because this returns a promise for a file. It doesn't return a file itself. Okay? I could save it to a variable, but it would be type. It would be the type promise file rather than being the type file. It's returning a different data. Okay, so this refile and that refile are not the same refile, just so we're clear. They look similar, but they're not. Okay, so this one, I'm going to then say then is a way to catch, say, okay, when that promise resolves, do something else. Okay, so when that promise resolves, it's going to give me back a file. So what I want. So I say when it resolves, take the file, and we want to do something with it. What do we want to do with that file? Per our synchronous version. What do I want to do with that file? Parse it. I want to parse it, right? So I'm going to say let's parse the CSV. And I'm going to make the assumption that parse CSV returns another promise. So both read file and parse CSV return a promise. And be done later. So say, read the file and then do this. And then, once the file has been read, then I'm going to say, okay, now I got my students. Let's console.log students 0. That looks a lot easier, doesn't it? I hope you can see why, like, just comparing those two, like, I don't want to do callbacks, I want to do promises. I just want to skip over to the promise API if I can. In fact, that's enough of a distinguishing thing that when I'm looking for libraries that other people have written, I'll just skip over the callback API entirely, and if they don't have a promise API, I'm going to pick a different library. Because it's so much of a difference. Now, one thing that's missing from here, have I dealt with any of the errors? I haven't, right? And it's worth noting with this, I can't deal with the errors using a try catch. Because the errors are thrown in context of this read file function, and this file function, and this file functions. They're actually, they come out as promise rejections, which promise rejections don't trigger a catch. Okay? So if I just write with this, if anything goes wrong, actually my program will crash. If I leave it like this. If I leave it like this, your whole server will go down. So, we need to handle the error. Handling the error is pretty simple. Catch. You say catch an error. Console. Error. And let's say we want to log that. That's it. So I stick a catch at the end, and that catches any errors with the read file, any errors with the parse CSV, and even any errors that might have happened with this console log or student. All of those errors. Anywhere, and we kind of call this a promise chain because there's a first link in the chain, second link, third link. It's kind of chained together. If anything goes wrong in the chain, this single catch at the end will catch all of those errors. Cool? That looks easy, right? So promises, you're not really familiar with them yet. Obviously, I really doubt you've done anything with promises or tasks in the past. But do you think you can handle it? You think that makes sense? Yeah. I think you guys can go ahead and skip on up to that and forget the callbacks exist. I'm okay with that because I'd much rather write code like that than the previous way. Okay. So this is a drastic improvement. Using promises is a drastic improvement over using callbacks. Behind the scenes, there's callbacks happening, but we've kind of split them out so we have like the success callbacks and the error callbacks are not mixed together, right? It's easier to kind of think of things linearly. Even though things are not actually happening from top to bottom, it looks like they're happening from top to bottom. Okay? So remember that I said there was 3 ways to do this, right? So there's 3 ways to do asynchronous coding. Everybody there with me? So what was the third one? Okay. So async await is another step, another layer on top of this that makes it even easier. Okay? This looks pretty easy. It can be easier still. Does everybody have this version written down before I erase it? Give people a chance to write it down.
one called again?
Huh?
What is this one called?
These would be called promises. This is dealing with promises. So when you're dealing with promises, you'll see this then and you'll see this attached. I have skipped over a few details, namely that I didn't define read file and parse CSV, but that was mainly as a way to try to keep this example simple. Because there'd be a lot more I'd have to write if we define those. Okay? All right. So let's talk about, let me show you what async await looks like. The same exact. So async await is this nice syntax. It takes advantage of promises. So you already have to have an API that gives you promises back. If you're not getting promises, if you've got a callback API, async await will not work. Okay, just so we're clear. You have to already be dealing with promises. But it gives you a way to write asynchronous code that doesn't look asynchronous. It gives you a way to write asynchronous code that doesn't look asynchronous. In fact, it's going to look very similar to the first example. So I started with a try, because it turns out you can do try and catch with async await, which is nice. I'm going to have, just again, I have the file name. Okay. Next thing I'm going to do, I'm going to do something I said was a no-no, because async await lets me do this. Const file await read file file or no file name. So you're seeing this await keyword right here. Okay. The way you can think of a wait keyword, it basically pauses the function until the promise resolves. It pauses the function that you're in until that promise resolves, right? So read file returns a promise. We wait until that promise is resolved, and then we save the result to file. Make sense? We wait until it's resolved, and then we go here. Next thing, const students. I'm going to wait for that promise to be resolved from parse CSV. And finally, console log right. Yep, it should just be file. Parse the file, not parse the file. How easy is that to read? The one on the right. I think it's pretty easy to go from top to bottom. And this is just the phenomenal thing with async await, is that it makes code that is very easy to read from top to bottom, and it looks like it's flowing strictly from top to bottom. In fact, so here's my synchronous version. Here's my async version. What's the difference? Almost none, right? There's only a small number of differences. What are the small number of differences on the right?
Await keywords.
Right, await keyword. That's it. The difference between this code and that code is I've got the word await. The other difference that's missing is that here, this directly returns a file, and this directly returns an array of students. Over here, read file returns a promise for a file, and parse CSV returns a promise for students. These are both returning promises instead of returning. So there is a difference in how those two functions are. Okay? Which does mean that these two functions are a little bit more complicated over here than they were over there. But my code that uses them is basically, is really simple. So this is what we want to do. Does that make sense? Like, this is how we want to write our code. A lot less scary, right? I did the first one, and some of you may have had almost a heart attack looking at that. It's like, what? But this is much easier. Okay. So where we can use this, we want to use this. Okay. I will say that for lab period 1, you're going to find yourself doing the callback situation. And that one you do have to do with callbacks. It's not a promise version, okay, for what you're going to do there. But this is where we're going. Is everybody good with that? You think you can handle this? Okay. Because most of the details end up being kind of hidden behind how promises work and how the APIs you're using are working. Namely that when we deal with the Mongo driver, Mongo is actually just going to make those promises for us. So we just need to say, I'll await that promise that Mongo is giving. Okay? One thing I kind of left out of this third example to mention, there is a caveat with async await. Notice I put in the word await. There's also a keyword async in JavaScript. There's a keyword async that you also have to include. Okay, I didn't show it here. Okay. Namely because in order to do this, this code has to be inside of an asynchronous function. This code has to be inside of an asynchronous function. So making a function asynchronous allows you to use the await keyword. If you don't make the function asynchronous, you can't use the await keyword. It's pretty easy though. So what that means is, let's say I call this function process students. One way for me to define this, async function process and put all that stuff inside. Okay. So if you're doing a function declaration, you add the async keyword here, and that allows you to put the await keyword inside of that function. Okay. If you're using a function, if you're using an arrow function, then it looks this way. you use the async keyword again. And it would look like so you add it before your parameter list. Cool. So in order to use the await keyword, you have to remember to be, you have to be in a function, and that function has to have the async keyword. Cool. One thing that this does, okay, so previous to adding this asynchronous keyword, what your function returns is what your function returns, okay? If you add the async keyword here, now your function returns a promise. So this function returns a promise. Does that make sense? This function is now returns a promise.
Are there overloads? Are there overloads for when the function may return comments versus returning counter? Or how does JavaScript know?
It generally doesn't. It's generally, it's oftentimes, that's the $1 million question. It generally doesn't. So you have to know ahead of time that it's going to return a promise or not going to return a promise. Does that make sense? So I need to know, does read file return a promise or does it return the file? Because depending on which it is, I'm going to have to call it differently. Okay? So it doesn't. So you have to then say, hey, if I want to use the output of this, right, the output of this is a promise, so then I either need to use then, say process students then, or I can say await process students, and then deal with it that way. So oftentimes you'll find, you know, async functions called by async functions called by async functions called by async functions. Yeah.
Okay.
Until at some point you reach the top. Okay? Actually, you're hitting on a kind of a pretty controversial kind of issue right now, which is something that's known as top-level await, where, you know, should you be able to use the await keyword all the way at the top of the script, not inside the function. Historically, you haven't been able to do that. Recently, there's been some changes to the way modules work, and there is a way to use top-level await now, but you have to be using ES modules instead of the traditional modules that you use in Node. Okay, so we'll still be using traditional Node modules for the semester as far as that's concerned. Okay, which means that we can't do await at the top level. Okay, because we have to actually change a bunch of things in order to be able to deal with it. All right, cool. So very good for this kind of async versus sync question. You understand why it's so important? Why it's so important to be doing asynchronous code?
It takes time to process that.
Yeah, it takes time to do a lot of things, so we're being more efficient with our resources. Here's the thing. So this is something that's relative, you know, asynchronous coding is something that's relatively new in the industry. You just need to understand that. It's relatively new. There's a lot of professional developers who are still new to this stuff. They're still getting on board with this. People like me who traditionally kind of came from that model of thinking about synchronous coding, we're used to this idea of thinking, oh, well, if I do await, then that's blocking the thread. Well, it's not actually blocking the thread. What's happening is the thread is doing something else while you're awaiting. This function's sort of on pause, which doesn't do something else. So it's not actually blocking the thread. It also means that the way JavaScript is built, JavaScript is strictly what we call single-threaded. JavaScript, the Node environment is entirely single-threaded. You can only do one thing at a time. Even though it looks like, oh, there's all these things happening, like these things happening out of order, and it may look like there's multiple things happening at once. There's always only one thing happening at once. So it's just swapping in, doing this, and then doing this, and then doing this. It's trading off what it's doing. So we still only have a single server, basically one waiter, in our whole Node application. Recently, there's been some additions to the language where you can now do workers, but that's and have basically additional waiters to do some more long-running jobs. That's outside the scope of what we're going to cover this semester. Okay. So as far as we're concerned, JavaScript is single thread. Okay. The single thread. The single thread. What that means is, as I said, we're using our resources better. Eventually, you find that you usually need more than one server to handle all your traffic as you get larger. We can still have the ability to run multiple servers. In fact, it turns out our single servers are so cheap, it's actually really not hard to run 10 servers. Say, hey, rather than just write, because a single server is so cheap, let's say, hey, this virtual machine is running 3 servers instead of just one node service. Make sense? So that's actually pretty common. It's pretty common for your virtual machine to be running multiple node instances rather than just one node instance because of that. Because it's so rapid. Okay. All right. So that gets you into kind of the weeds of JavaScript and what modern JavaScript looks like. I hope you've seen, there's been a lot of refresh in there, but I'm sure there's been a bunch of stuff that you haven't seen before. And that's okay. Like the whole asynchronous discussion, that's going to be something you probably didn't see in your previous year of college, right? That's okay. So what we're going to do next thing on my agenda is talk about console applications, okay? So I'm going to go now back to VS Code, and we kind of played around a little bit in the weeds, jumping around, writing different things. What I actually want to do is kind of make a small little program. So I'm going to create a new file here called test scores. .js. Okay. And so basically what I'm going to do is I'm going to build up a small little program. It's going to ask the user to repeatedly enter test scores until they enter done. Okay? So when they enter done, then we're going to finish out the application and give them the average of those scores. Everybody good with that? So that's what I'm trying to build. So one of the things that I didn't talk about so far is how do we get input from the user, right? How do I get input from the user? Because I want them to type in some numbers. And so this is one of the things that you're going to need for the lab, okay? So Node has some built-in APIs that you can use, some built-in libraries and classes and a variety of things. So what I'm going to do is I'm going to go look Node read line. So there's this read line module, okay, and we can bring that in. I'm going to link this in. It's on the lab. It's linked on the lab, and I'll also link it in Discord. Basically, it allows us to say, "Hey, I want to ask the user a question, and then I want to show, and then I want to get their input, right? So it allows me to ask them a question, get their input. Ask a question, get their input. Okay? Good so far? So in Node, there's this require function. It's a global function. Require allows us to bring in code that's either part of Node, is from NPM, which we haven't talked about NPM yet. I'm going to have to talk about that tomorrow. Or it allows to bring in other modules that you have written. Okay? So require allows us to bring in code basically from other files. Okay? So we're going to use require read line. We're going to bring that in. And we're going to follow along with what they have there. Now, they've brought in read line like this, and then they're doing something with an RL. I'm going to simplify this a little bit, so I'm actually going to do these 2 lines of code in 1 line, if that's okay with everybody. So I'm going to do that actually similar to what they've done, but slightly different. So in here, I am going to say const read line is equal to require read line. And I'm actually going to directly call create interface on that. Create interface takes an object with 2 parameters. So one is the input stream, which is where we're going to read from. And that's like they have there, process.standardIn, and output, which is process.standardout. All that does is says I want to read from the terminal and I want to write to the terminal. Otherwise, I could be reading and writing from a file, is the alternative to that. So every program has a standard input, every program has a standard output. Okay? So now that I've got that set up, I can start asking some questions. So I'm going to say read line dot question. And so question takes 2 arguments. The first one it takes is the question I want to ask, the text I want to write out. The second one is a callback. So let's say, what is your test score? Or maybe I just say enter test score. Maybe let's keep that short. Enter test score. All right. And then I've got a callback. And that callback's going to get what they typed in. Okay. Now this doesn't do any parsing of those numbers. It always returns a string. So it's always going to give me back the answer that they gave is always going to be a string. It's not going to parse that to a number. Okay. So if I do a simple let's say I just start with this console.log, and I'm going to log their answer. Okay. So let's try to run this now. So node test scores scores.js. If I type in test, it's going to immediately spit that out, but notice it doesn't finish. Okay. One thing to kind of catch in there is that if you want the program to actually close and finish, you do at some point have to close the read line. If you're stuck here, right, you'll notice this program is kind of stuck, hung, running. There's no way for this program to end. It's not really it's not an infinite loop. It just will never end. Okay, so on the console you can do Control-C, and that will terminate the program. Okay. I do need to call it quits today because we're at 4:25, so we'll have to finish this tomorrow. I'm going to go through the last bits of this and get you started on the lab. But this is kind of like what I'm going to be asking you to do on the lab. This kind of is to write some console applications. So if you want to, you can kind of play around with this over the break and get started with Lab 301 tonight. Tomorrow I'll finish this up and get you started on that.